Okay, so can you guys hear me now? Because apparently the mic didn't want to work and stream or uh yeah. Let me try to clear this up and get this sorted out. Oh boy. So it's been an interesting evening, folks. So my guide scope died, or guide scope camera died. It will not connect at all for any reason. And now that pedal board's working again, let's see if I can get better mic quality. Can you guys still hear me? Okay, so that seems to be a bit better. Alright. So yeah, my guide camera died, unfortunately. Then I don't have an automated focuser, so it's kind of hard to... I gotta keep running in and out to get stuff set up. Plus, the Empress had a field trip, and the bus was late getting back. So yeah, it's been a fun night. A fun night. Alright, so that blob in the center of the screen, let's go ahead and do this. And then do this. Hold on. There we go.
It's either Mars or Jupiter.
Mars or Jupiter? We'll say hello.
Hey, it's me, and today I am going to be in this live stream.
So,
And I got some stuff from the field trip. I have one of the items here. You can't see it, which is sad.
I have to zoom in a bit.
So, as Daddy said, we have been having some technical difficulties.
Oh yeah, and then on top of that, as you can see, any of you astronomy folks, oh boy, the air is super unstable.
That's Jupiter.
No, it's not. That's Mars.
Okay, so right now we are looking at Mars.
It's just the air is really bad tonight. And the sad part is that, well, this was going to be the only clear night for a while to be doing this. So, yeah, I'm not quite sure what to do at this point.
I have a doll here right now.
Okay, so what I'm gonna do is I need to make myself a cup of coffee or a very strong drink. I'm not quite sure which.
I think coffee might suit you better.
It's also been a rather interesting evening because none of the software, Star Chart software, was syncing correctly, so yeah. But I am live now.
So
I wonder if I can bring that in a little bit more.
the
There we
doll
go.
I have right here is a...
Oh, hold on. Yeah, I'm not even sure if that's worth trying to capture, because the air is, as you can see, the air, folks, is super unstable. So it's like shooting through water. Lots and lots of turbulent water. Kind of like, yeah, rapids. But anyway, I am going to go make myself coffee or a very strong drink, and again. Wow, this is getting pretty bad. Yeah, so now the mount won't actually sync correctly for some reason.
I think it's broken.
It better not be.
Well, it's likely.
No, I don't think the mount's broken. I think all the software is broken.
I think your software
That's a
changed.
little too much.
I think your software
Let's go back.
changed its settings. I think your software randomized its settings.
I would not be surprised, actually. I would not be surprised. Because I also needed to do a Java update for a piece of software, and now for some reason running the same piece of software, Java alone eats 4 gigs of RAM. Anyway. So, folks, how y'all doing tonight? Let's see if folks can hear us.
Caps.
Yeah. Can you hear us okay?
Yes, we can hear you.
Okay. So at least somebody's watching.
So it turns out that we have someone in the stream. A very special person in the stream, actually.
So, I'm gonna go make my coffee.
And I'm gonna tell my kids' cruise story.
Yes. Well, first you have to tell them what the kids' cruise is. Go ahead and have a seat here.
I will take over your channel.
Oh God, no. Now, hold on. Because when doing astronomy, we have 1, 2, 3, 4, 5 different windows open, and then that's on top of doing the whole production side for live streaming. So yeah, give me a second. Let me try to organize this. There. So now we can actually kind of sort of see chat. And apparently it is not on sidereal tracking, which is another issue. Current object. Think. Come on. Think. There.
Okay.
Alright. So, why don't you tell your story about the kids' cruise and what the kids' cruise is and stuff like that. Okay?
So I will be explaining a few subjects to you. And I will be taking over Backyard Observatory. So...
Wait a second.
I
need to give somebody a wrench. Just because. There we go.
Catchen Studios, you now have a wrench.
Or a spanner.
No, just say she has a wrench.
Or a spanner.
Wrench!
Spanner.
Wrench!
Spanner.
Wrench!
Spanner.
Wrench!
Spanner.
Wrench!
Okay. Wrench. Spanner.
Bruh.
Alright, go ahead and explain your kids' cruise.
Okay, so what the kids' cruise is it's a special field trip according to this year. it's a special field trip where you can have lots of fun. Where you can have lots of fun and you get to you know.
How do you get selected for it?
So how you get selected for it is so they can only take 50 students.
Yes, well, that's beside the point. How do students get selected?
I don't know.
It's because they're exceptional students.
So they get accepted because they have been good and they have shown the cam way.
So keep going on.
And so what happened? So here's what happened at the kids cruise. Our first stop was Walmart, and we had a $30. Oh no! I accidentally hit the mic. Sorry guys, I accidentally hit the mic. So our first stop. So the first stop was Walmart, and the students had a $30 credit card.
It's a gift card.
And we got a $30 gift card. So we now have we got plus $30.
So you got okay, well, keep telling them.
And what I got is I got a bling glow stick set, which I accidentally activated the glow sticks and which I accidentally activated one of the glow sticks. And also I got a costume cutie, and I have removed the costume. I've removed the costume, so now she is a normal human instead of a parrot. And it comes with a little...
You need to pay attention, chat.
Okay. And it has a little, it has accessories, such as skirts, the jacket. The jacket is part of the costume.
Oh, folks, I'm running a normal latency, to get a little bit better quality. So it will take us a little while to respond to... There will be a delay for us responding in chat. To stuff posted in chat. Just to let you know.
And so right now I have the costume cutie doll without the costume, and one of the accessories is glasses, plastic glasses. I kind of wanted the monkey one, though. I kind of wanted the monkey one, because... However, the costume cutie that I got was the parrot. And the wings are the skirt. So you can change the entire costume to a normal outfit. Except the head, though. The head, once you take off the head, you can't put it back on. At least I don't think.
If I take off my head, I can't put my head back on. Unless I have duct tape and super glue.
Brew.
I'm just having fun.
And also a surprise is it comes with a pet. It comes with a pet. And also you can use warmth to change how the character how the thing looks.
Oh, so you went on your kid cruise, you went to Walmart,
Yeah.
went on a shopping spree, then what else happened?
Then I met Santa. It was very amazing. It was very amazing. And there's no denying way I can say that this wasn't real. This was not a dream. This was...
Santa's not from Mars. He's from another planet.
Bro, he's from Earth.
No, he's not. He's from another planet.
He's from Earth. Sorry about that, guys. I didn't mean to yell. So like you can like with the doll you can take off their you can rip off their makeup just by putting your thumb over the makeup. You can literally rip off their makeup. And you can also do the same thing with the pet. However, the pet, when you put warmth over its eyes, then the eyes close. Right now, there is a cat beside me. There is a cat in the chair beside me, and it's a really cute cat. So the kids' cruise is a special field trip. And I had pizza for dinner on the kids' cruise. And eventually we had a snack, and the snack was a brownie with candy in it. I don't know what candy it was, but it was some sort of candy. Excuse me. It was pretty. I mean, the kids' cruise was pretty fun. It was pretty fun. I'm not lying to you. Let's see if I can get my doll to do yoga. To do the single leg extension. Yoga test. Oh, I'm sorry. Sorry, but I hit the mic again by accident. Ah! And turns out my doll can do yoga. I'll see if my doll can do the tree pose. If my doll can do the tree pose, then she is a yoga master. Oh my goodness, she can do the tree pose. So my doll can do the tree pose. Let's see. Let's see if she can do the plank. I think this will be quite difficult as she does not have wrist articulation. Oh wait. Oh, darn it. I knocked something over, guys. Hold on. I need to bend over glasses. I accidentally knocked over a pair of glasses. So I think you got so I named my doll Jessica because I thought that was a nice name. She kind of looks like a Jessica. So, oh wait, I shook the disc. Okay. I don't know what else to talk about. Can you do the... I'm testing if my doll can do the grounded V. She cannot. I literally don't know what to talk about right now.
So what you doing?
I literally don't know what to talk about right now.
Oh, okay. Well, I'll be back in a second.
You'll be back in a second?
Yep.
What do you mean?
Another second.
What do you mean?
No.
And I seemed to have hit the mic again. Sorry about that. I was testing if the mic would pick up if I hit it by accident. Oh wow, I can make her face palm. I can make her face palm.
You're silly.
I don't know what else to talk about. Please
Okay.
help. Please help me.
Well, how about this? You hop out of my chair. Hop out of my chair.
But your chair's comfy.
I know. That's why it's my chair.
Wow, her arm's broken.
Now move the kitty.
I don't know if I want.
No. And I'm doing a little adjustment to the position of Mars. So just curious, folks. How is Mars looking out there?
I cannot get this girl to wave because her arm.
So Loretta says, "Is that home? Is that home planet on the screen?" Yes, it is. Yeah, it being jittery is due to turbulence in the air.
Just wow.
So, I mean, I tried to dial in focus earlier and was even having problems with that because I was using a star for focus and was even having problems with that because everything was kind of icky. I mean, I might try to focus this a little bit more. Maybe? I'm not sure if I could get it any better or not.
Oh, darn it. Sorry, guys. I accidentally bumped my foot on a... What is this called?
Well, for now, it's a cabinet. Now, I'm going to try to take a look at something. 1/3 crop. Let's get the proper scope up. And 2x. And let's see what would happen if I pointed this over towards here. Ooh, that would be like just the dead center of the Orion Nebula. I wouldn't be able to see much.
This is what people would be like when her ship lands and they're in the way.
Oh no!
Like
You're so cute.
She has her hands in front of her face because the lights are bright.
So, as I promised, we will be showing, well, for those of you interested, this is what I'm this is what I'm imaging at right now. 4.85 milliseconds at about 300 gain. And of course, it messed up there, but
sunglasses are now a weapon.
now maybe the once it passes the meridian and gets over on the west side, it'll be a little bit cleaner. The skies will be a little bit better. But like I promised earlier in the description, I have some stuff planned.
This is what I'd be like fighting the others.
You're silly. So I'm going to mute the mic and let this run. Let me scale this up a bit.
Today we begin the first of 3 talks dealing mainly with the planet Mars, a planet rich in legend and fable and tradition on this planet, and a planet about which we have recently in the last few years discovered an astonishing amount of new information. But I would like to begin not with Mars, but with a discussion of the nearest planet to the Earth, Venus. Venus, remember, is covered with clouds. We cannot, if we go to a telescope such as this, or a much larger telescope, look through it and see any features on the surface of Venus. If I look through a telescope of this sort, which is a sort of typical 19th century telescope. Of course, usually they were not inside rooms, but in observatories, so you could look out. Actually, this is pointed out the window in the back of the Royal Institution, and I can see upside down Dent and Company across the street. Were Dent and Company not in the way, I could probably see some overcast in the London sky. on the rare occasions when the overcast were gone and it was night, I could see whatever tiny portion of the sky was in that little patch. Now, if you were to use such a telescope, this one is about 4 inches aperture. The diameter of the lens is 4 inches across. If you use a telescope like this, or a bigger one, say with an aperture or objective of that size, on reasonably clear days, you could make out Venus as a disk going through phases, shimmering, silvery, enigmatic, interesting. Prolonged scrutiny would reveal no details at all. Observers in the 18th and 19th century used the fact that you couldn't see anything on Venus to deduce all sorts of interesting information about Venus. The argument went like this. My goodness, I can't see a thing. Why can't I see a thing? Venus must be covered with clouds. What are clouds made out of? Water. Everybody knows that. Well, there must be a lot of water on Venus. There's a lot of water up in the atmosphere, then there must be a lot of water on the ground. Maybe there are swamps on Venus. And from there, it was but a short step to a Venus populated by dinosaurs, covered with ferns, and like the Earth of a few 100 million years ago. Now, we all recognize that this argument, which was, by the way, presented by a Nobel laureate, is weak. And in fact, Venus is not covered, so far as we know, with swamps, ferns, or dinosaurs. But it indicates to us that astronomers are human like everybody else, and no matter how little data there is, they will find it irresistible to make guesses, or as they're sometimes called, hypotheses, about what the planets are like. As more data comes in, the range of speculation that's possible shrinks until eventually there comes one fine day when there is only one possible explanation of the data. In the case of Venus, what happened was that in 1956, American observers with a large radio telescope found to their astonishment that Venus was giving off very intense radiation. Not a radio station, but a so-called thermal spectrum. It was noise. But it seemed to indicate that somewhere on Venus, things were pretty hot. Was it in the atmosphere, clouds, high up in the ionosphere, on the surface? Where did the heat come from? A set of observations, including observations by the first spacecraft to fly by another planet, Mariner 2, in 1962, showed that the emission was coming from the surface. And we now know that Venus has a dense, thick atmosphere, rich in this molecule, which we recognize, I hope, from the last lecture as carbon dioxide, which holds in or traps the radiation which the planet likes to give off to space. Sunlight gets through the atmosphere of Venus, warms up the surface, but the infrared radiation from the surface has difficulty getting out because of the trapping influence of this gas, carbon dioxide, and small quantities of water. This is called a greenhouse effect, named after the way a greenhouse is supposed to work, but that isn't the way a greenhouse works, but never mind. It's another mistake rich in the tradition of the subject. Venus is, in fact, at an astonishingly high temperature, 900 degrees Fahrenheit, that's 750 degrees Kelvin, even though it's only a little bit closer to the sun than the Earth is. And the greenhouse effect is almost entirely responsible for this high temperature. In addition, the pressure on the surface of Venus is 90 times the pressure in this room. We would be crushed by the pressure of the air on Venus. And the atmosphere, while it is mostly carbon dioxide and has some water, also contains quantities of unpleasant gases like hydrochloric acid, hydrofluoric acid, sulfuric acid, and the like. It's an exceptionally nasty place, and in fact, Venus is very much like the classical description of hell. If you want to know where hell is, it's the surface of Venus. The clouds of Venus, which are very interesting, are composed mostly of concentrated sulfuric acid. and it's not a nice place to go visiting to. Now, despite the dense clouds, we are beginning to gain information about the surface of Venus. How can we do that? There are two ways. One is using radar, which penetrates the clouds, strikes the surface, bounces back off the surface to the radio telescope on the Earth. Some places are bright in the radar image, some dark, and we get a picture of the surface of Venus. The other way is to actually land on the surface and take pictures and look around. So an early map of the surface of Venus looks something like the next picture. You can see some vague bright markings on the surface. Those are places which like to reflect radar waves. Were we to use a more advanced radar telescope, which has been developed as time goes on, we begin to get close-up details. So here is a portion of the surface of Venus, and we see places which are bright, places which are dark. This place we see here, which is bright, we can look at more closely, and it is a place which has been called Maxwell. Many of the bright prominent features on Venus are named after pioneers in the study of electricity and magnetism, because it is electricity and magnetism which is behind the use of radar telescopes. There's another lovely feature named after Michael Faraday, who gave a lecture at 6 lectures at the Royal Institution at this time, 150 years ago. Why is Maxwell bright? Well, it may be a mountainous area which reflects radar very well. There are, we think, mountains on Venus, volcanoes, craters, valleys. The configuration of the surface of Venus is just beginning to be understood. The Soviet Union has successfully landed on the surface of Venus 2 unmanned spacecraft. This is a photograph taken by Venera 9, and we can see rocks, mottled ground, and away towards the top right, what looks like the horizon. There are rocks on the surface of Venus which don't look all that different from the surface of the Earth. That is extraordinary, because the forces which erode rocks on the Earth don't exist on Venus. The principal reason that rocks are eroded on the Earth is because of running water. The surface of Venus is much too hot to have any liquid water at all. Another thing which erodes rocks on the Earth is wind-blown dust. But we know, both from theory and from direct observation, that the winds at the surface of Venus are very slow, even though they're very fast in the high atmosphere, and not enough to move dust. What then is rubbing down the rocks of Venus? It is a mystery. 2 ideas which have been proposed are the terrible acids in the atmosphere, which may be slowly eating away the rocks, or it may be that the high surface temperature melts some low melting point component of the rocks, and so there is a slow change in shape of the rocks, a smoothing out as time goes on. Well, we don't yet have many pictures of the surface of Venus taken close up, but it may be that sometime in the next 5 or 10 years we will have views like this artist's conception of what the surface of Venus may be like. It may be very different from this as well. We are in the earliest stages of exploration. Now, the older astronomers not only proposed that Venus was a kind of swamp, some proposed that it was a vast desert like the Sahara. Some proposed that it was an ocean of carbonated water, and some proposed that it was a vast planetary oil field. The fact that 4 such different ideas could all be held on the basis of the same data shows the enterprise of the astronomers in the absence of supporting evidence. We now have a good idea what Venus is like. It's not like the Earth. The analogy of the Earth was with us from the beginning, because Venus is the same size and mass and approximate position in the solar system as the Earth. But Venus is a very different place. Now, these warnings are important when we start to study Mars, because Mars has also been thought to be a place in many respects like the Earth, that we have placed our hopes and fantasies, wishes and desires on. And we must be cautious that our wishes do not blind us to the reality of a planet. Now, exactly a century ago, in 1877, two discoveries were announced about Mars, which will dominate the rest of this talk. One is the announcement that there were canals on Mars, and the other, the announcement that two moons had been discovered going around Mars. Now, if we look at Mars through a telescope, we do not see a crisp, sharp, lovely image. We see a blob of a few colors which is changing its shape. It isn't even circular. Sometimes you see a little blob piece breaks off, as if Mars is dividing up. And you're lucky if you can see the polar cap, if the polar cap is visible. You're lucky if you can see any surface features. Mars is often a disappointment to the amateur astronomer looking at it for the first time. Where are all the features I've read about? I can't see any of them. The reason has to do with the Earth's atmosphere. The Earth's atmosphere is turbulent. It moves, and light which passes through it is bent. And it's a little bit like if you're having breakfast in the morning and there's a toaster between you and, let's say, your brother or sister. You're looking at the face of your brother or sister, and suddenly the ear seems to waft off into space. The reason, fortunately, is not that there's anything wrong with your sibling's ear, but that the hot air rising from the toaster is distorting your view. And that's exactly what we have to deal with in looking at planets from the surface of the Earth, and is an excellent reason to get above the atmosphere of the Earth. But the observers of the last century were stuck on Earth, as we no longer are. And let me try to show you the problems which they had to deal with. We have here a modern map of Mars showing much more detail than the 19th century observers knew about, and a container of water above it. It's going to be illuminated from below and reflected in this mirror and go into the television camera. Meanwhile, Mr. Coates and I are going to dip our fingers in the water and make irregular waves, and the cameraman has defocused his camera, and this gives a faint sense of what Mars looks like through the telescope under ordinary seeing conditions with a reasonably good telescope. Maybe now the cameraman can focus up just a little bit, and occasionally an improvement, more detail. For just a moment you can see something like this, and then the Earth's atmosphere unsteadies, the image becomes less well focused, and the problem of the 19th century observer was to draw what he saw. If we could focus up again, I just can't resist doing this. Okay. Now, thank you. That was the problem. There was something to be seen, but only in fleeting glimpses, unpredictable glimpses. You couldn't photograph it because you couldn't tell the camera when to take the picture, because you didn't know when the atmosphere would be steady. The eye could remember when the atmosphere was steady, but the eye is not a perfect recording instrument. The best that can be seen by photography from the surface of the Earth is shown by pictures like this. Now, I'm going to show two photographs of Mars, and there are two features which I would like to show you, I'd like to call your attention to. I will, later in this talk and in the next talk, show what they are. In this picture, the dark feature at the very center is the darkest feature on Mars, and it is called Syrtis Major. We see that Mars has bright areas. It has dark areas. It has a polar cap made of some kind of snow. We know that the cap waxes and wanes with the seasons. There are occasional clouds. There's one here and one over here. It is a planet about half the size of the Earth. If we follow a certain feature, let's say this one, and see how long it takes for it to reappear as the planet rotates, we can find out what the length of the day is on Mars, and astonishingly, it's about 24 hours, just like here. The planet's about half the size of the Earth, so it has about a quarter the surface area, because the area is 4 pi r squared, as everyone in the audience surely knows, for a circle, for a sphere. And that's roughly comparable to the land area of the Earth. So even though Mars is smaller than the Earth, it is a big place for exploration. Things change. We see clouds. We see the polar caps change. And it's a reasonable place to think about what's the ground like? What's the atmosphere like? Could there be life? How did the planet come to be? Is it as old as the Earth? Questions which are difficult to approach if we are limited to this kind of detail. Here, the feature I'd like to call your attention to is this one right here called Solus Lacus, the lake of the sun. The people who named these features were very good at Greek and Latin, and those of us not so good at Greek and Latin have to struggle with the names. Now, these are photographs, but as I mentioned, much more detail can be obtained from drawings. Here now is a drawing of this same region, Solus Lacus, by a 19th and early 20th century observer named Antoniadi. And here we have, again, the Solus Lacus region, but much more detail in this picture. We see all sorts of little circles, and we see some hint of irregular, almost straight lines in this picture, but not lots of them. Also, we see coloration, sort of blue-purple to the dark areas, which we did not see in the previous photographs. Now, this same region was observed by others who saw it quite differently. Here is a drawing of Mars made by an American astronomer of the turn of the century named Percival Lowell. Here is Syrtis Major, the same region I showed you photographed before. But what is striking in this picture is all these funny straight lines. It looks like a cobweb. All over the disk, straight lines. They were called canals. And Lowell truly believed that they were canals. Here is a region near Solus Lacus, and we see that the whole Solus Lacus region is radiating with canals going in all sorts of directions. Again, the canals, the most striking aspect of the Lowell view of the planet. Now, what did Lowell believe these canals meant? Lowell believed the canals were canals. Reasonable enough idea. Lowell said that the straight lines could not possibly be the product of geology or meteorology. They had to be the product of biology. There were too many of them, they were too regular, they were too straight. They had to be produced by a race of intelligent beings that inhabited Mars. Lowell's idea was that Mars, being a small planet with a low gravity, water had escaped from the planet in large quantities and now was a parched and desiccated world. The intelligent inhabitants made a big effort, according to Lowell, to conserve what water there was, and so made a planet-girdling network of canals which captured the runoff in the spring from the polar caps and funneled them to the thirsty inhabitants of the equatorial cities of Mars. And as a result, we have a view of Mars, which we've made a little model of right here. And here we see, slightly out of focus, the blue water and the green verdure along the banks. And as we scan down the banks of the canal, we come to a joining with another canal in a place which Lowell liked to call an oasis. And there at the oasis, we see something. Old Christmas ornaments, I believe Mr. Coates has told me they are, but they here represent an exotic Martian city. And people around the turn of the century seriously believed, and it's not an impossible idea, it's not ridiculous, but they seriously believed that there were high civilizations on Mars. Now, to give you an idea of Lowell's own views on the subject, he talked from this place in the year 1900-something, 1910, about the canals. And here's what he said on a Friday evening at the Royal Institution in 1910. He said, "To begin with, you should know that the lines you will see," that's the canals, "are certainties, not matters admitting of the slightest question, for all their strange regularity, and so seen by all those who, from the most prolonged and careful study, are qualified to speak." He says, others have described them as laid down with rule and compass. And not only I, says Lowell, but all of my assistants who worked for him have seen them thousands of times the same. Nor are they near the limit of vision in our air, in Lowell's special observatory in Flagstaff, Arizona, in America, which sometimes sets the planet against the sky as if etched in a steel engraving. Then he says, the technical word canals does not mean canals that are dug, but artificially fertilized strips of country connected with and vivified by the turning to such account of the melting of the polar cap. Lastly, I may say that by saying that organic life exists there, we do not mean human beings. Well, Mr. Lowell was very certain. The trouble is that lots of other astronomers tried to find the canals, and very few of them could, using equally good telescopes from equally good places. And so there got to be a lot of skepticism about the canals. Yet some astronomers saw them. What could they be due to? Well, let's do a little, very simple experiment. I have here some irregular pieces of polystyrene, this lightweight material, and here a felt black backdrop. And I'm going to try to just spill these on the backdrop in as random a way as I can. And since they fall through the air, that helps to randomize the patterns. Okay, now I would like to ask you to look at this and tell me if you think you see some straight lines or small segments of straight lines. Is there anybody in the audience who sees little straight lines in this? Could you raise your hand, those of you who do? Lots of people see, no, not straight lines everywhere, but some straight lines. May I ask you to show me the straight line? It'll be very painless. Come on down. Show me what straight lines you see. There's one there, good. One there, one there. There, good. So now, how many pieces of polystyrene does each of your lines have?
Well, depends.
Roughly, how many?
About 6.
6, something like that. Good. Thank you very much. You've been a big help in deciding on what the canals of Mars may be about. I appreciate your help. Now, what is the lesson from this? It's that if you have an irregular pattern of fine detail, the eye, which enjoys order, sees apparent patterns where the little dots seem to connect up in a straight line. There's no way of making such an array of dots without occasionally seeing a straight line. So many observers thought that was the explanation of the canals. And we can here see a description of just such a point. Here is a region of Mars, which you can see has lots of lovely canals. And we're going to dissolve this region into another description. Here is a drawing. What a beautiful dissolve that was. A drawing of just the same region as seen by Antoniadi. And notice he sees virtually no straight lines, just disconnected fine detail. And now if we can dissolve back and forth, we can see how the eye might have drawn in those moments of temporary good seeing a straight line where there was only disconnected fine detail. But the problem is much worse than this, because we have now examined Mars closely with spacecraft, with much finer detail than Lowell could possibly have obtained. And we can look at all the regions where he drew canals. And here is a map which we drew at Cornell University of most of Lowell's canals against the features which are truly on Mars. And with one or two exceptions, there's no connection whatever. It isn't that little dots were strung up accidentally by Lowell and his followers. It's not that simple at all. There is nothing in most of the places where Lowell drew canals. And therefore, we must conclude that the canals of Mars are an indication of the inaccuracy of the human hand-eye-brain combination. We are not perfect observers. This is, by the way, a comment relevant to reports of unidentified flying objects as well. We do not report things always accurately, no matter how hard we try. And particularly when our emotions are involved, when we'd love to have a certain answer, our results are not of the highest accuracy. Now, there were two other kinds of arguments which Lowell used for life on Mars. One had to do with color, and the other had to do with seasonal changes. Now, Lowell and many other visual observers reported that the dark areas of Mars were green. We have not seen them green. We've seen in the photographs that they're sort of irregular gray color. But we can understand how it is that the dark areas may have been reported green. And we've prepared a little experiment, and let me describe what this experiment is about. First of all, the argument went like this. Lowell said, my goodness, the dark areas of Mars are green. What do I know on Earth that's green? Well, plants are green, so there are plants on Mars. That was the argument. You can see that's not a very good argument. It's about as good as the one for dinosaurs on Venus. But the question is, are the dark areas of Mars green? So what we've done here, we'll need the lights down a little bit, is to reconstruct obviously this doesn't look extremely much like Mars, but it's an irregular pattern, a dark area and a bright area next to each other. And I ask you to just check whether, in your view, I'll make a poll in a moment, whether in your view the right-hand part of this looks green. It certainly does to me. The left-hand part is a kind of pink. Now, what actually is happening here? What's happening is that we have a red irregular feature and a white disk. The white disk is surely white. But when we make the red pattern close to the white, the eye attributes to the neutral white region the complementary color. And the complementary color to red and orange is blue and green. So this is a kind of optical illusion, another failure of the human eye. Can I just take a brief poll? I won't be angry if nobody saw green, but will those who did see green please raise your hands? Virtually everybody. Thank you. So here again, a kind of problem with the human eye. Finally, Lowell saw changes on Mars. And here he was not mistaken. There's no doubt that there were changes. And we can see some of these changes. Here are three views of the same area of Mars, the Solus Locus area of Mars. And let's first do a close-up of the left-hand region. Good. Now, we see a large polar cap, which means it is winter, right? In winter, the polar cap is large on Mars. In spring, it is small. We see a only moderate contrast between the bright and dark markings. Here is the Solus Locus region. Now, if we can dissolve into the next image, lovely. This is the same region, but now in spring. We see with a small polar cap. And now the contrast between bright and dark features is much greater. Lowell argued that what is happening here is that as the polar cap melts, the waters are carried down to the vegetation near the equator, and the vegetation grows, darkens the ground, and that's what's happening. These seasonal changes surely happen. We have them on photographs. Maybe they're due to vegetation. Maybe they're due to something else. That is a topic we'll cover in the next lecture. But let us now dissolve to the third view here. And here we see a vast, irregular, bright patch which has simply covered over the dark markings underneath. At the same season of the year, we see the small polar cap. Lowell correctly understood this to be a great dust storm, in which dust was carried by the Martian atmosphere over and obscuring the dark material. And those dust storms are important, and we will refer to them many times again. Now, I would like now to turn to the second great discovery of the year 1877. This one, a real discovery, the moons of Mars. Now, the moons of Mars had been an idea that was around for a long time. In fact, we can find it in the most unlikely places, in a story called Micromegas by Voltaire, and in the famous book by Jonathan Swift called Gulliver's Travels. It's an interesting place to find the moons of Mars, especially before they were discovered, but here it is. Volume 2, 1766, printed for C. Bathurst in Fleet Street. And this is something that happens to Gulliver when he goes to the floating aerial island of Laputa. This is not Lilliput, and it is not Brobdingnag, but Laputa. And it is probably good not to know Spanish to think of Laputa. The comment which Swift makes is the following. He says, "They have extended their discoveries much farther than our astronomers in Europe. They have likewise discovered two lesser stars or satellites which revolve about Mars, and then describes the distances of the moons from Mars and how long they take to go around the planet." And these turn out to agree with a relation first announced by Johannes Kepler, and he says that this evidently shows them to be governed by the same law of gravitation that influences the other heavenly bodies. Now, how could Jonathan Swift have known about the moons of Mars? He didn't get the distances and the length of the month exactly right, but even there he came pretty close. How could he have gotten the existence of the moons of Mars correctly? How could he know? There are many proposals on this, including one that he was a Martian. But there is excellent evidence that Jonathan Swift was not a Martian. He was very much a terrestrial. Well, we have to go even earlier in history in order to answer that question. Unlike the novelists and writers of romantic fiction of today, people in Jonathan Swift's time knew something about science. And in particular, there was the idea which had been first formulated by Johannes Kepler in the 16th century, that Mars had two moons. Kepler's argument was tremendously simple and naive. And it went like this. We'll use our orrery again. Kepler said, look, here's the Earth. It has one moon. Here's Jupiter. It has 4 moons, the 4 big moons that Galileo had discovered. That's all they knew then. Here's Mars in an intermediate position. Well, if it's in an intermediate position, it probably will have an intermediate number of moons, said Kepler. Why not? So what number is between 1 and 4? Well, that was well known in the 16th century, 2 or 3. But Kepler liked 2 because he liked geometrical progressions. He was a fan of geometrical progressions, 1, 2, 4, 8, 16. He loved such things. And so he said Mars has 2 moons. Now, it's a silly argument, and what's more, Jupiter doesn't have 4 moons. It has 12 or 14 or 20 or something like that. They're being discovered every month. And the argument breaks down even if it were a good argument. But Kepler was a famous astronomer, and for very good reasons. He was very clever, but he made mistakes, like everyone does. This was one of his mistakes. But what happened was people remembered the conclusion and forgot how silly the argument was. Said, Kepler says there are 2 moons. So people believed there were 2 moons, although no one had found them. Then in the year 1877, a new telescope was completed outside of Washington, D.C. at the United States Naval Observatory. And the astronomer Asaph Hall decided it would be a nice thing to go out and discover the 2 moons that everyone knew existed, but unfortunately no one had yet seen. And so he went out and looked, couldn't see anything, looked again, couldn't see anything, came home discouraged, and told his wife that this was foolhardy and he was giving up the search for the moons of Mars. His wife told him that she would hear no such thing, and he was to go right back to that telescope and find those moons of Mars. And he dutifully marched off to the telescope, and that very night found the first of the 2 moons of Mars. He called the 2 moons Phobos and Deimos, after the 2 horses which pulled the chariot of Mars, the god of war, in Roman and Greek mythology. And he was astonished on the first night to see the innermost moon in one position, and the next night to see it in quite a different position, and he couldn't figure out what was happening in putting together the observations on successive nights. And the reason for that problem is that Phobos, the innermost moon, is an extraordinary object doing an extraordinary kind of motion, which we will try to duplicate here. Here we have a model of Mars, and protruding on 2 metal pipes are 2 gray-covered spheres which represent Phobos and Deimos. Phobos at about the right distance from Mars, but Deimos would have to be somewhere out to here and would collide with the telescope and me and various things, so we've made it closer to the planet. Now, here we have the moons going around roughly at the right speed and Mars going around at roughly the right speed. And what do we see? We see that Phobos, the innermost moon, goes around Mars faster than Mars itself turns. Now, on the Earth, we're accustomed to objects rising in the east and setting in the west. Why do they do that? Because the Earth is turning from west to east. But on Mars, you would see something extraordinary. Since Phobos goes around faster than Mars does, Phobos would rise in the west and set in the east. And it would do it very fast. In fact, there are many times on Mars, if you live near the equator, when you could see Phobos rising in the west at sunset. It would then set and then rise again before dawn. You could see it rise, set, and rise. But only if you lived near the equator, because if you live near the pole, you can't see it. Mars is in the way because it's so close to Mars. Now let me see if I can stop the moons from revolving. That's very difficult. Good. Now, The discovery of these two moons, first Phobos and then Deimos, was announced. It was thought to be important. Here is a reproduction of a page of the London Times for Tuesday, September 4th, 1877. And there, beneath a large map on the progress of the Bulgarian War, is a small article sent by telegraph on the satellites of Mars, saying that the observations that were made in Washington had been confirmed at the Paris Observatory, making them reliable. Now, the moons of Mars are too small to see with even such a telescope. All you can make out is a point of light. You cannot make out in the extended disk. They're tiny objects. So people interested in studying the moons, what could they do? More or less the only thing of interest was to observe the motion. And so this was done. And when the motion was observed, a strange thing was discovered. It was found by precision observations that the orbit that Phobos followed was not a perfect circle. It was instead something like a very faint spiral. The moon was slowly approaching the planet. And you can calculate at the present rate that Phobos approaches Mars when it will collide with Mars, and that will be in about 100 million years. We better stop it so it doesn't do it sooner than that. Now, 100 million years is far into the future, but still is short compared to the age of Mars in the solar system, which is about 4.5 American billions of years. And it's an interesting thought that Phobos will plummet into Mars and collide with it in the relatively near future, at least on the geological timescale, and suggests that other moons of Mars and other planets may have collided with them earlier in their history, and that great basins formed by such impacts might exist on the planets. And that's a topic for a later discussion as well. Now, why does Phobos have this strange spiraling motion? The Soviet astronomer I.S. Shklovsky is an extremely clever and creative astrophysicist, one of the best in the world, and he considered this question in around the year 1960. And he thought of all sorts of reasons it might do this, make this motion, calculated what would be required, and concluded that it couldn't happen. He then returned to the idea that Phobos was spiraling in for the same reason that artificial satellites in the Earth's atmosphere spiral in, because of drag by the thin atmosphere of Earth or Mars in the appropriate case. But Phobos is not a very large object, but we have a rough idea how big it was, and Shklovsky thought it was maybe 10 or 20 kilometers across. That's a very massive object. It's very far from Mars, so the atmosphere there must be very thin. How could that thin atmosphere slow down, drag this massive satellite? Well, the only solution Shklovsky decided was that the satellite wasn't as massive as we had thought, and the only way to have that is to have Phobos hollow. Shklovsky proposed that Phobos was an immense object 10 or 20 kilometers across, which was empty on the inside. He correctly pointed out that no natural object can be hollow in that way, from which he concluded that it was not a natural object. He proposed that Phobos was an artificial satellite of immense proportions orbiting Mars. The biggest artificial satellite that we've managed is about the size of this auditorium, and therefore to make one the size of the inner city of London would require some civilization much more advanced than we are. And since there is no sign of such a civilization on Mars today, Shklovsky proposed that there once was such a civilization, but that it is now extinct. Now, that's a chain of argument which may remind you of some of the arguments of Percival Lowell, but notice that it's based upon observations that are at least real. Phobos does have that kind of spiral motion. Well, as a result, it would be very nice to take a close-up look at Phobos. What would an enormous artificial satellite 10 or 20 kilometers across look like? Right? That's something we surely like to know. And if it's not an artificial satellite, well, we could certainly find that out as well by examining close-up pictures of Phobos. Our first opportunity to do this came in 1971 when the United States put into orbit around Mars a spacecraft called Mariner 9. It was the first space vehicle to orbit another planet. It arrived in the midst of a great planet-girdling dust storm. There was essentially nothing whatever to be seen on Mars. I had previously proposed to the management of this mission that we should plan on looking at Phobos and Deimos, but they had a big book, and they looked in this book and said, nowhere in this book does it say anything about looking at Phobos and Deimos, so you can't look. And I thought about that a little bit, and then went back and said, the most likely origin of Phobos and Deimos is that they are captured asteroids. If we look at Phobos and Deimos, we then won't have to go to the asteroid belt, and we could save $200 million if you let us look. They said that that was a much more reasonable argument than the last one, and said maybe we could look. And then when we arrived at Mars and found there was nothing to be seen on Mars, they said, by all means, look, how nice of you to think of this. So we looked. And in late November of 1971, we obtained our first close-up view of Phobos, and it looked like this. Now, not much to see, right? But this is before the picture was computer contrast enhanced. And after, late that evening, we were able to make that same picture into this one. And what is it? Well, there seem to be a number of holes on it, which are probably craters, a giant one up at the top, and others in various places. And I don't know what a giant artificial satellite looks like, but this doesn't seem to be it. This looks more like a diseased potato. A few weeks later, we came very close to Phobos, about 5,000 kilometers away, and obtained this view. And we can see that it is an old, battered, irregular object. In fact, it turns out to be about as old as the solar system. It has seen large numbers of collisions. It does not seem to be an artificial satellite. And now, more recently, with the Viking mission, we have been able to obtain still closer up pictures. And here we can see a set of quite remarkable furrows and grooves running along here. In fact, the Viking spacecraft was able to be maneuvered within something like 100 kilometers of Phobos. We could have crashed it into Phobos if we wished to. It would have been stupid, of course, but we could have done it. And close-ups of these grooves have also been obtained. The reason for these furrows or grooves is still being debated. One interesting idea is that they are produced by the tides of Mars. The gravity of Mars is tearing at Phobos. And perhaps in time Phobos will be torn into pieces by these tides. And perhaps that is the origin of other fragmented features, for example, the rings of Saturn. It's a possibility. Also, Phobos is a very dark object, and now it appears to be made of organic material, and therefore may say something about the pre-biological organic chemistry in the early history of the solar system. It is a fascinating object. I'll say something more about it in a moment, but let's take a brief look at Deimos. You can see Deimos is not quite the same as Phobos. It does seem smoother. The two large craters that you see here have names, one of the marvelous things about this kind of exploration is we can name things. And we can put all our favorite people on these objects, provided they're dead. And so the two craters you see here have been named Voltaire and Swift, after Voltaire and Swift, for reasons which I've already described. Now, Phobos itself looks like this. This is a model of Phobos, made after Mariner 9, but not including any of the recent Viking data. And you can see what an irregular object it is. It has seen catastrophes. It is mute witness to cataclysms in the early solar system. Pieces have been broken off. Holes have been gouged. Things were very violent a long time ago in the vicinity of Phobos. Here is a great piece that's been carved out. In fact, some people think that Phobos and Deimos were once both part of the same object, which was split in some great catastrophe and broken into two satellites. Anyway, the big craters here we have named. We certainly wanted to name one after Hall. He discovered the moons, after all. But we also wanted to name one after Mrs. Hall, because there seems to be good evidence that they would not have been discovered without Mrs. Hall's urging. But we can't call both craters Hall and Hall, because then who will know which one we're talking about at any given moment? So we had to find out what Mrs. Hall's maiden name was before she became Mrs. Hall. Not so easy to do. And I once was giving a lecture at Harvard University in which I complained about how difficult this was. And a colleague of mine, Owen Gingerich, professor of the history of science at Harvard, who was in fact in England at this moment, stood up and said in a loud voice, "Angelina Stickney," he said, which is, in fact, Mrs. Hall's maiden name. And so we have two important features on Mars called Hall and Stickney. Hall is here, quite nice, large, but Stickney is here, and is in fact the largest feature, largest crater on Mars. And so I think we have done the appropriate kinds of commemoration. Now, there is a kind of lesson. The moons of Mars are without doubt of extremely great interest. And they are either captured asteroids or pieces left over from the formation of Mars. And if they are truly rich in organic matter, but even if they're not, they are objects well worth deep study. But the idea that they are artificial satellites is surely wrong. Just as the idea that Mars is covered with green vegetation is surely wrong. Just as the idea that Mars is circled with a network of canals constructed by a race of beings enamored of hydraulic engineering is wrong. These ideas were proposed before there was enough data. They were charming ideas. They were driven in part by our interest in the possibility of life elsewhere, and that is an important goal, to look for life elsewhere. But they also were, to some extent, distorted by our interest in finding life elsewhere. And there is a lesson. The lesson is, accept only the most rigorous standards of argument. Do not accept inadequate, poorly thought out, flawed arguments, especially where our emotions are involved. And that's a point which will be most important when we consider in subsequent lectures the possibility of life on the surface of Mars with more sophisticated instruments. Now, since these early times, many more observations about Mars have been found. For example, one such observation made from a high-altitude aircraft, not by a space vehicle, is a spectrum. The brightness of Mars versus wavelength. Brightness in the vertical scale here, wavelength in the horizontal, showing an absorption feature, this dip. It's very much like the spectral lines we talked about in the last lecture, and this is due to water. Not liquid water, but water chemically combined with the rocks and soil of Mars. It's a very big feature, and therefore means there's a great deal of water on Mars. Could some of it be in the liquid form? We don't know. But at this point, we don't know. But the existence of lots of water on Mars is a slight encouragement for those who like to think about the possibility of life there. The possibility of life on Mars has infused itself into Sunday supplements and science fiction and romantic novels, starting, by the way, with Percival Lowell's marvelous but erroneous popularization. And so, for example, it's possible to go to places as far afield as Peru and see, in this case on a door in a rural place in Peru, a sign which says, "Se vende marcianos," here we sell Martians. Now, if only that were literally true, we could save ourselves a great deal of effort by just going to Peru and purchasing a few Martians. But it turns out that those Martians are candy bars, rather like our Martians, both in the United States and the United Kingdom. There are Mars bars, which have nothing to do with Mars, so far as I know, except that Mars is thought to be a nice thing. The idea of looking for life on another planet is a splendid idea. It is properly a focus of our enthusiasms and our interests. But, as I said before, we must be very careful about the kinds of arguments we use. The only way to really find out about life on a planet like Mars is to go there, and therefore it requires close-up space vehicle exploration of the planets. Thank you. Thank you. Today, we go to the subject of the spacecraft exploration of Mars. Quite a different story from the exploration of Mars using ground-based telescopes that we talked about in the last lecture. The typical interplanetary spacecraft of the present time is a machine about as big as this lecture table. It may weigh half a ton or a ton, something of that sort. Is launched by a large rocket booster from someplace like Florida or Soviet Central Asia. Takes something like a year to go to Mars, about the same as it took British merchantmen to go to the Far East in the 17th or early 18th centuries. The spacecraft is unmanned. Unmanned missions are much less expensive than manned missions. They also are much more obedient. The spacecraft could fly by a planet. It could go into orbit around the planet. It could enter the planetary atmosphere. It could crash into the surface. There are some that are designed to crash. Most are unhappy if they crash. And there are then spacecraft designed to land on the surface of a planet. Mars has seen spacecraft fly by, spacecraft orbit, spacecraft crash although accidentally, and spacecraft successfully land. Today, I'm going to be talking about the first space missions to fly by and orbit Mars. They were all called Mariner, and you can see there's some hint of that nautical exploratory tradition even in the name of the spacecraft. And the first was called Mariner 4, which went by Mars in 1965. Mariner 6 and 7 went by in 1969. And then the main subject of this talk will be what was found, the remarkable findings by Mariner 9 in 1971 and 72. This is a model of a typical such spacecraft. This is, in fact, the Viking orbiter. You can see the 4 big solar panels, look like panes of a windmill, that convert sunlight into electricity to power the spacecraft. There also often is a battery which can drive the machinery of the spacecraft during times, for example, when the spacecraft passes behind the planet and so cannot see the sun. The spacecraft receives commands from the Earth with a big radio antenna, and usually it uses the same antenna to send the data back via radio to the Earth. And all of the communication goes over this extremely long path, which may be as much as 50 or 100 or 150 million miles. The spacecraft has its own little rocket motor and fuel so that it can adjust its orbit, change its orientation, do things on the basis of what it finds. And then, of course, it has science. Here is a scientific payload which can scan. It's called a scanning platform, and it has the ability to follow Mars as the spacecraft goes by or orbits the planet. And here you can see 2 cameras, and there are many other instruments as well. The spacecraft typically could last for at least a year and maybe many years in working mode. The spacecraft is to some degree intelligent. It has a computer on board. It has pre-programmed instructions. It has a long list of stupid things not to do, which it constantly checks out. Am I doing something stupid? Am I doing something stupid? And if it turns out that it is doing something stupid, it often knows how to correct that error. The computer can be reprogrammed from Earth so that the controllers on the Earth can decide to do something different. The controllers are in a large room in the United States at the Jet Propulsion Laboratory in Pasadena, California, and looking continuously at reports from the spacecraft about its internal health, how well it's doing, if any parts are failing, if it has enough power, if the temperature is right, and so on. And commands are sent from this command center. The commands go via land lines to a large radio telescope. This one is in the Mojave Desert in Goldstone, California. It is 85 feet in diameter, and it will send a coded radio message to the spacecraft at Mars. And the spacecraft knows how to read and interpret that information. Likewise, when the data is sent back, which it is on a regular basis, it is sent back to such a radio telescope, which then sends it to the scientists that are waiting in Pasadena for the data. There are such radio telescopes for the United States, not just in California, but also one in Spain and one in Australia, so that as the Earth turns, there is always a radio telescope pointing towards Mars to be able to get the data. Now, when Mariner 4 first flew by Mars in 1965, it took 21 pictures, the first photographs ever taken of Mars close up. And it could see things much smaller than could ever be seen from the Earth. It could see things a few kilometers across. And what it found, essentially the only thing that was visible in those pictures, were craters. And craters at that point became an important part of the study of Mars. Now, people know that the moon has craters. In fact, there are some craters on the Earth as well. And it was very interesting that an argument soon was raised that said, this proves that Mars has no life on it. And sometimes the argument went as follows. The moon has craters. The moon is lifeless. Mars has craters. Therefore, Mars is lifeless. Now, I hope that many of you will see that that is not a terrific argument. And you can imagine various arguments of that sort that don't work. My eyes are green. My nose itches. Your eyes are green. Therefore, your nose itches. And other arguments like that. That's not a good argument, but we heard it. In fact, we even heard the President of the United States, a Mr. Johnson, say that he was pleased to find that there was no life on Mars. And the reason that he was pleased was because he said that as a young man he had been frightened by a radio broadcast about an invasion from Mars, which was based in fact on an H.G. Wells story of the same name, and that since he did not want an invasion, he was glad to find there was no one on Mars to do such an invasion. Well, this was an opinion which could be heard expressed by others, including the American divine Billy Graham, and shows that not only are there people who badly want there to be life on another planet, no matter what the evidence says, but there are people who badly want there not to be life on another planet, no matter what the evidence says. And the proper posture of a scientist, I believe, is to find out what's really there, independent of what people want. What we wish to be true is one thing, and it's important for our motivations. But what is out there may be quite a different thing. And it is always, I believe, important to be humble and open and questing in face of the truth. Now, the whole question of craters is an interesting one. What are the craters and how do they get made? We know that there are a large number of craters, let's say, on the moon. I'm going to come around here, and for a reason which you will shortly see, I'm going to put on this coat to protect me. Thank you. The solar system has lots of rocks in it. Big rocks, small rocks, medium-sized rocks. Some of them are in the asteroid belt, where they range up to several hundred kilometers across, and they are sort of worldlets. Now, today, most of these small and large rocks are on regular orbits, which don't intersect. Collisions are few. But at the early history of the solar system, when material condensed out of a cloud of interstellar gas and dust to form the sun and the planets, at that time, there must have been many more such rocks, and they didn't know they were supposed to be on regular orbits. So they did intersect, and there were enormous numbers of collisions. Now the solar system has been cleaned up by all these collisions, and they happen rarely. But in the case of, say, the moon or Mars, we see signs of those early catastrophes. And such craters happen today as well. For example, Meteor Crater, Arizona, is about 1 kilometer across and was produced by an impact of a big rock falling from the sky. Big rock falls from sky, makes hole in ground. Easy to understand. The reason there are so few craters on the Earth and so many on the moon is not that the rocks in the sky know they're supposed to land on the moon and not on the Earth. Oops, I'm going to the Earth, I better move over here to the moon. No rock knows about that. It's that the holes in the ground are rubbed out on the Earth better because we have running water, we have windblown dust. Those are erosive agents which can fill in and rub out craters. So just as many, more or less, craters are formed on the moon as on the Earth, but the ones on the moon survive because the moon does not have many erosive agents, and the ones on the Earth disappear. So what often happens is something like that. Yes, I should warn the people in the front rows that this is going to be dangerous. And in fact, I shortly am going to call for volunteers, which will make it even more dangerous. So, the rock falls into the ground deeper than the thickness of this tray and makes a hole bigger than it itself was. And sometimes there is a lip. Sometimes there is a central mountain. Sometimes a set of rocks fall from the sky simultaneously and make some sort of pattern. Occasionally there's a crater overlapping another crater. And there are lots of things that can be done. Also, it's fun. Sometimes rocks miss planets. That's all right. We have to have some rocks left. Now, I think I need some volunteers who will enjoy making a mess of the Royal Institution. Good. May we have you and you. And I need one more volunteer, you in the green tie. And be careful that you don't step on any asteroids. And what I would like you to do is to take some handfuls of marbles, it doesn't matter what the object is, and one at a time, but pretty fast, start throwing them onto the moon. Might be Mars, and I'll join you. Okay, so... Okay, terrific. All right, we have one sticking up. Good. Okay, I think we have made a good first step, but let's try a few more. Just, but don't throw. Let's just drop them in. Okay, we don't want to throw them hard because it'll destroy. That's right. Excellent. Good. Lovely. I'm going to now poke a few that are still sticking up down because there are no marbles to be seen on the moon. And I'm not sure exactly what I will now do with this piece of moon. Thank you very much. And I'd like to thank you for your help because this is an important business of making craters on planets. And very few have a chance to do it. So maybe you can surrender your robes. Thanks. And I thank you for, oh, we have some asteroids left. Thanks very much. Now, let's take a close look. Mr. Coates can hold up a mirror at the results. And I think we got a lot of holes. Now, this is very close to what's called saturation cratering, where there are so many craters that one overlaps another, and you have hardly anything but craters and their debris. Now, that is the case in certain parts of the moon, but not in other parts of the moon. And I think it would be nice for us to spend a moment looking at the moon and seeing whether it bears some resemblance to what we've just seen. So now here is a photograph, in fact it's one we've seen before, of the moon. And the two major parts of the moon are the high, bright, heavily cratered areas and the low, dark, lightly cratered areas. The latter are called maria, which is Latin for seas or oceans, because Galileo thought that these were in fact oceans. They are not. They are perfectly dry, bone dry. You can see a number of craters. Here, for example, is a dark crater. Here is one with a bright center. Here's another dark one. And as we look closer, we find tens of thousands of craters larger than a kilometer or so across. And a typical such crater is this one. We see the central mountain peak in the middle, which we did not find in any of our craters that we made in the Royal Institution a minute ago. But we understand the reason for that. It's produced by a rebound phenomenon, which could not have happened in this mud. We see the slumps at the crater walls, a kind of terracing. Sometimes there is debris which is thrown out by the impact. it is very similar to what we find in the laboratory. Now, the big basins on the moon, some of them are very large, many hundreds of kilometers across, are also produced by impacts, by bigger rocks falling. And I would like to show now a sequence of pictures showing how features on the moon probably formed. In the early history of the moon, in its final stages of formation, lots of rocks and debris were falling in, and there must have been an enormous number of craters to be seen. And here is an artist's view of how the moon must have looked in the final stages of its formation. But there were still some rocks to be acquired by the moon, and here is one in the process of hitting the moon, liquefying some of the surface layers, producing an enormous explosion, which then led to a multi-ringed crater, a sort of tidal wave, successive waves from the impact spreading out and then being frozen in the, as the lava, the hot rock, freezes. Then, either through the energy of the impact or through internal heating of the moon, molten rock welled up and flooded these lowland basins produced by impact. And here we can see the dark frozen lava, and also the little hint of red in the picture is due to another impact happening on top of this. Then you can see in this picture that the dark low regions have very few craters on them. As time passes, no new major events occur, but new minor events occur, and these maria accumulate a sprinkling of additional craters over the following 4 billion years. Now that's a typical view of how major basins and craters form on the moon and on Mars. And so we expected there to be lots of impact craters on Mars. We had seen them from previous missions. And so when Mariner 9 was sent to Mars, we expected lots of craters. But the previous spacecraft had only looked at about 1% of the planet. So we didn't know whether all of Mars was covered with craters or if only small amounts of Mars were covered by craters. Turns out, as we will see in a minute, that something like half of Mars is heavily cratered and half of it is not at all heavily cratered. Now, what does it mean that a region is not heavily cratered? It means that it's young. It hasn't been around long enough to accumulate all these scars of ancient cosmic catastrophes. What does it mean that a region is heavily cratered? It means that it's old because it has been around long enough to accumulate all of these craters. So the cratered regions of Mars must be old, perhaps going back close to the beginning of Mars, about 4.5 billion years ago. And the uncratered regions must be young. As with the case of Phobos and Deimos, if we find craters, we can name them. And the only rule is that the people we name them after have to be dead. Fortunately, there are many dead people, and some of them even did some notable things in their lives. So in this particular region of Mars, for example, there are craters named Lowell, after Percival Lowell, who did a great deal for the study of Mars, one of the major ones of which is to excite 11-year-olds into thinking about Mars. Many of the generation of present planetary astronomers were first excited about Mars through Percival Lowell or Edgar Rice Burroughs, who wrote terrible romantic fiction based on Lowell's view of Mars. There is Maunder right here. He's a British astronomer who proposed that the Lowellian canals didn't exist. There are a large number of geologists, astronomers. There's a crater named Huxley, after Thomas Henry Huxley, who was a great supporter of Charles Darwin and gave lectures at this Royal Institution. There are even a few science fiction writers, including H.G. Wells, who have craters named after them on Mars. Now, when we arrived at Mars, when the spacecraft arrived at Mars in late 1971, we discovered that there was a planet-wide dust storm and virtually nothing could be seen on the surface of the planet, except in one place, a place called Tharsis, where we could see some strange features. And since this was the only place where we could see any features, we, of course, spent some time worrying about them. So here they are. You can see 3 dark spots or marks all in a row. Since you had 3 marks in a row, some of the more clever scientists proposed naming them Harpo, Groucho, and forgotten the name of the third, Chico, thank you. But reason prevailed, and they were called by appropriate scientific names North Spot, Middle Spot, and South Spot. The dark spot over here is exactly in the position of a feature which had been seen by 19th century observers and called Nix Olympica, the snows of Olympus. And such a lovely name that we called this spot Nix Olympica. But what were they? Well, the first thing we tried to do is to, with a computer, enhance the contrast of these pictures to bring out more detail. And you can see that that's what's being done. For example, here. Here is a close-up of Nix Olympica. Well, what do we see? We see a dark smudge which seems to have a hole in it. Now, let's pause just a moment before going on to these pictures and think, what does a dark smudge with a hole in it mean? Well, why are we seeing these features at all when the planet is covered with a great dust storm? The only thing which makes sense is that these are features sticking up above the dust. Well, what is a sort of roundish feature that sticks up above the dust? It must be a mountain. But this is a mountain with a hole in it. What is a mountain with a hole in it called? A volcano. Everybody knows that. Thank you. So, this is the physicist's approach to figuring out what these things are. If you have a big mountain with a hole in it, it's probably a volcano. There is another approach to this problem. It's the geologist's approach, which is look closely at it, and if it looks like a volcano on the Earth, then it must be a volcano. Another good approach. So we attempted to look more closely at all of them. Here is an attempt to look at the computer-enhanced version of Middle Spot. And what do we see here? Another smudge with a hole in it. Well, the geological approach was frustrated for a while. Time went on, the dust storm dissipated, and eventually we got much better pictures of these features. And here, in the next picture, is an example. This is a close-up of Middle Spot. Ignore the rectangle which is put on Mars by us and doesn't exist on Mars. And you can see this enormous mountain. Here is the base of it. Here it is going steeply up. Here is a big hole in the top called the caldera. It looks exactly like terrestrial volcanoes. Case proved. And here is a close-up of the largest volcano in the solar system, so far as we know, Nix Olympica, which is now called Olympus Mons, which means Mount Olympus. And whether there are any other famous individuals from classical mythology that live there as well, we do not know. But this is what Mount Olympus on Mars looks like. We are looking straight down the caldera, and let me describe what we have here. Here, on the right, is a flat plain here, which is the Tharsis Plateau. It is already very high. Here is a sheer vertical cliff, 1 to 2 kilometers high. Then we slowly walk our way uphill. The slope is modest here, very steep here. Then we come to the caldera, and there's a steep plunge in. Going to the other side of the caldera, we go down quickly here, slowly here, come again to the cliff, and go down to the Tharsis Plateau. From the base to the high point is almost 30 kilometers, almost 80,000 feet. It is a volcano which dwarfs, both in height and in lateral extent, any volcano on the planet Earth. And notice that there are virtually no impact craters. Here's one. There are almost no others. On the flanks of these volcanic mountains, they are therefore very young. A rough estimate makes them no older than hundreds of millions, perhaps 1 billion years old. You may think that's rather elderly, but it's young compared to the age of Mars. Mars is, in recent times, geologically active, which is very different from the case with the Moon, and shows, and there are many other things which show it, I'll come to them shortly, that Mars is by no means an object like the Moon. It is active in the sense that the Earth is. On the other hand, it has places which are very poorly eroded, like the Moon. It is a different place from either the Earth or the Moon. Now, volcanoes. We are going... This is Dirty Up the Royal Institution Day, and we have here a model of volcanoes. What is a volcano? Hot lava under hydrostatic... it was a rhetorical question. Under hydrostatic pressure, comes up a point of weakness in the ground, flows out, makes a mountain, and as the lava continues to flow up and overflow through the central caldera, the mountain continues to build. In the course of this, great clouds of ash are spread into the atmosphere and spread out on the flanks of the volcano. Well, we don't have really 4 volcanoes here, but we have a very good imitation of it. And if Mr. Coates will make the volcanoes go, we have a... You see, here's volcanic ash spilling out on the floor. Notice how the terrain is discolored and great cloud of smoke rising to the roof of the Royal Institution. If we were lit by sunlight instead of artificial lights, it would have gotten somewhat darker because the cloud of volcanic smoke would have prevented sunlight from coming in. Now, that happens when real volcanoes go off. They spread ash for great distances, they darken the sky, and they, in fact, cool the planet. And it is possible that in the time, 1 billion years ago or so, when the great volcanoes erupted on Mars, that there were substantial changes in climate, which were the result of those eruptions. Now, I will come back to the question of climate change in a little bit, but right now I would like to go on to the next nice thing we found in the Mariner 9 mission. In looking at the polar caps, we found we could see them through the dust because they had high contrast. And here you can see 4 pictures of the polar cap. This is the south polar cap. The north polar cap looks very similar. And here you can see an outrider, a piece of frosted ground, which we see here in the 14th day of the mission, but here, by the 21st day of the mission, it has entirely gone. The cap is receding. The frost is vaporizing, going on into the atmosphere, going away. Here, if we take a close-up look at day 36, we see strange gulfs and gullies into the polar caps. And this is absolutely characteristic of the polar caps in both parts of Mars. And here we have an artist's impression of what it would look like close to the polar caps. And you see this sense of stacked plates, great poker chips piled one on top of another, each tens of meters high. And then off in the distance towards the horizon, another set of poker chips piled one upon another. These are features totally unlike anything we know on the planet Earth. The fact that there is a feature and then another feature after a pause, another feature after a pause for each of the poker chips suggests that on Mars there are events which turn on and off. You make a piece of this great laminated terrain, and then the process that makes it stops. Then after a while it starts again. Then after a while it stops. That sounds like changes in the climate, but on a massive scale, as if Mars is at one time balmy and another time ice age. And astonishingly, there is still other evidence suggesting that that's the case. Because as the dust storm really cleared, and we could see smaller, less obvious details on the surface, we discovered a range of extraordinary features that look like what we see here on the left. We here have a valley, but a valley with sinuosities in it. It meanders back and forth on itself. Also, a valley with tributaries. Here, for example, or in here. It looks very much like a river. And on the Earth, there are rivers which look extremely like this particular feature. This is the Red River in the United States, and let's compare it back again with Nirgal Vallis, which is what this is called, on Mars. These features are remarkably similar in appearance. They seem to be produced by running water. Here is a quite different place of Mars with beautiful braided patterns and sinuosities, tributaries, collapsed banks, teardrop-shaped islands in the middle of the valley. It looks for all the world like a feature produced by running water. So now, having splashed mud on the Royal Institution and spread smoke and ash into the atmosphere, we now want to pour water on the floor. We have here an irregular surface. Imagine it on a much larger scale than it is, with great boulders and a strange source of water here. And now the water is going to move in some direction. Oh, look at that bifurcation, whatever it chooses to do. And we're going to let this run for a little bit and come back to it in a minute to see what the general configuration that it leaves is. If we look at rivers on the Earth while we're waiting, I hear an uncomfortable sound of running water behind me. I'll pay no attention to it. We see there are places where beautiful braided patterns exist. This is in the terrestrial Arctic. And there are other features which might look as if they were a river valley. This feature right here, for example. But it is not a river valley. It is a collapsed lava tube. Lava has made a channel for itself under the ground, and the overburden has collapsed, permitting us to see the course through which the lava flowed. This has sinuosities in it, but not tight meanders like terrestrial rivers often have. It rarely has tributaries. It is morphologically, in its form, different from terrestrial river basins. So we think it very likely that what we see on Mars is produced by running water. Now, if we can take a look, maybe with a mirror and me out of the way, at what we have made here, we see something which looks rather like a river valley. Can I just reach my hand in and point out this little island which has been left right here, which is a feature very much like that that we see on many Martian river valleys. What we never see is a thumbprint. Well, we now must come to the question of how do you make rivers on Mars? Because there is an aspect of the Martian environment which doesn't permit rivers to be formed, and that is that it is extremely difficult to have liquid water on Mars today. The atmospheric pressure is so low that if you had an open pool of liquid water, it would immediately evaporate and boil away. So it is very hard to have water around long enough to be able to carve a river which is hundreds, or in some cases 1,000 kilometers long. that suggests that the rivers, which weren't made yesterday, we can tell from their craters that they're quite old also, that the rivers were made at a time when the Martian climate, the Martian environment, was very different from what it is today. And that suggests massive climatic change on Mars. Now, at that time, we would have rivers forming. Here is a laboratory demonstration on a large scale, larger than we were able to do here, of water first flowing in a straight path, and then in a sinuous path, and then lovely braids forming. Well, there was a time in the history of Mars when that happened. That is probably not happening today. There was therefore once a time when Mars had higher pressures, higher temperatures, and abundant surface liquid water. That is, when Mars was, in these senses, much more Earth-like. Today, Mars has a low atmospheric pressure, is on the average quite cold, has very little surface liquid water. It is in a deep ice age. Now, how can you have such a massive change in climate, even though it's over a period of hundreds of millions or billions of years? Well, the first thing to remember is that the Earth has had massive changes in climate as well. Here is a model of the Earth, and we have taped to the top of it the maximum extent of the polar cap at the time of the last great ice age, some 10 or so million years ago. And we can see that it's extended down quite far into Europe. London miraculously has escaped being covered by ice, but Chicago is buried under 2 miles of ice, which must make things uncomfortable for anyone who lives in Chicago some 10 or 20 million years ago. And today, by comparison, the polar cap is extremely small in the Arctic region, and all those places like Canada and Scotland are perfectly free of permanent ice. Now, how did that happen on the Earth? There are many views, and some involve the fact that the Earth has an orbit around the sun, and sometimes the Earth is closer to the sun, sometimes further. Sometimes the polar cap of the Earth is tilted more towards the sun, and sometimes further away from the sun. That's one possibility. Another possibility is that volcanoes on the Earth have made ash and fine particles in the atmosphere which prevent sunlight from striking the surface and cools the Earth. And there's a large number of other possibilities. In fact, there is a club of people who worry about how to make ice ages on the Earth. And to belong to this club, you have to invent a new reason. And there are, at last count, some 80 members. So you can see that there are lots of reasons proposed, and it's unlikely that they're all correct, although more than one could be correct. Now, in the case of Mars, there are similar possibilities. And let's just spend a moment on what those possibilities are. Here is a globe of Mars. Why don't we turn the sun on, always good to do when we talk about climate on a planet. And maybe we could dim the overhead lights a little bit. Good. Now, one possibility is that the sun itself gets brighter and dimmer over long periods of time. Let's see if we can dim the sun. Oh, good. There goes the sun dimming. We must imagine great ice ages happening on Mars, the atmosphere condensing out at the polar cap. And now if the sun were to brighten up some, brighten sun, thank you, then we imagine the polar cap vaporizing, more atmosphere pouring into the air, enough pressure for water to run on the ground, rivers forming, and so on. Well, that's one possibility, because the sun might be a variable star. Another possibility is that there are times when the polar cap of Mars is pointed towards the sun, and at that time, polar cap vaporizes, more atmosphere, running water, and times when the polar cap is averted from the sun, and things get very cold up there, and all the atmosphere rushes away to freeze out in the polar regions. There are many other reasons proposed for climate change on Mars as well, and I've mentioned just a couple of them to give you some feeling for the kinds of events we're talking about. But these are grand events. They're on a planetary or solar system scale. It would be very nice to understand what they're about and to see whether causes of climate change on Earth and on Mars are similar or different. It might be that we could learn something about changes in the Earth's climate by examining changes in the Martian climate. Since we are poking about the Earth's atmosphere, making changes in the Earth's atmosphere and surface, it is possible that we might inadvertently, accidentally make major changes in the Earth's climate. It is important to study other planets as cautionary tales of what not to do with the Earth. Now, there is another consequence of these climate changes. If there was once a time when Mars was warmer with higher atmospheric pressure and more liquid water, doesn't that mean that there was once a time when Mars was more conducive to life of a terrestrial familiar sort than it is now? The Martian atmosphere, we knew by the time of the Mariner 9 mission, was composed mostly of carbon dioxide. The total pressure was only about 1% or a little less than it is here. It's about the same as the density of the Earth's atmosphere at an altitude of 100,000 feet. The air is quite thin on Mars. In addition, there are small quantities of water vapor, of, we now know, nitrogen, of oxygen, although much tinier quantities of oxygen. The amount of oxygen in the Martian atmosphere is much too little for us to breathe. And even smaller quantities, I'm dropping molecules, even smaller quantities of ozone, a form of oxygen which has 3 oxygen atoms. Now, this is actually not the best model of ozone. It does show 3 oxygen atoms. Now, could life exist in such an environment? What about the temperature? Well, the warmest it ever is on Mars is about what it is in this room, which is consistent with life, but a little on the high side. But that very night, the temperature would drop some 100 or 150 degrees Fahrenheit. The temperature changes, say 100 degrees centigrade, 80 to 100 degrees centigrade. The temperature changes are enormous on Mars. There is not enough oxygen. The small amount of ozone has an important consequence. Because there is very little ozone, ultraviolet light from the sun penetrates through the Martian atmosphere to the surface. That doesn't happen here. We get very little of ultraviolet light from the sun because it's all absorbed by our ozone. If the ultraviolet light penetrated through the atmosphere, we would be in bad trouble, among other things because our hereditary material, our DNA, likes to absorb ultraviolet light and to fall to pieces and to make chemical bonds which are not consistent with accurate reproduction of the genetic code. Now, under these conditions, it seems that Mars is not a very likely place for life. But we can do an experiment. We can make a chamber which duplicates all of these Martian conditions, the temperature, the atmospheric composition, and pressure, and the ultraviolet light. Such chambers are, of course, called Mars jars. And we can inoculate the Mars jar with terrestrial microbes, bacteria, let's say. And when we do that, we find that lots of microbes do just fine. There are some that gasp and die for lack of oxygen. There are some that freeze to death. There are some that get fried by ultraviolet light. But there are many that enjoy those conditions extremely well. And if there are tiny quantities of liquid water available, say between little adjacent grains, they are able to reproduce. So the Martian environment is consistent even with some kinds of terrestrial forms of life, and therefore we should by no means exclude the possibility of microscopic forms of Martian life. That doesn't guarantee their existence, of course, but what we know about the Martian environment suggests that they might be there. And particularly if there were an earlier epoch when conditions were much more balmy, then perhaps the possibility of life on Mars is even greater. Now, this was one of the interesting conclusions from the Mariner 9 mission. in many people's minds, it had raised the likelihood of life on Mars. There was, among Percival Lowell's arguments for life on Mars, one which at least wasn't based on erroneous data, and that is that there were seasonal changes on Mars. We talked about some of them in the last lecture. Here is a different kind of seasonal change which he observed, and in fact which does exist on Mars. Here's the North Polar Cap, and you can see that it is surrounded by a dark collar of material which in fact follows it on its retreat each spring and summer towards the pole of Mars. Lowell thought that what was happening was that the polar cap was melting, wetting the ground, and that the moisture encouraged plants to grow and proliferate and darken the ground. The same idea was supposed to explain the seasonal changes which we talked about in the last lecture. But Mariner 9 found a set of changes on Mars at all scales, big and little, which seemed not to be produced by vegetation, but rather by something quite different, by wind-blown dust. Here we have a nice region of Mars where the contrast between bright and dark markings is high. There's no frost here. And we're going to look at two regions. This one over here, which I will call the leaf. It's a big leaf. It's about 10 kilometers across. And this region, which is, as you see, serrated. There's another similar thing at the bottom of this crater, but we will not examine that. Now, here is a view of the leaf area, but with no leaf. And just 13 days later, we took another picture of this region, and there was the leaf. In less than 2 weeks, this major region, 10 kilometers across, developed. Now, could this be the growth of vegetation, or might it be that the dark area was obscured by overlying bright dust, which then blew away by the wind, revealing the dark material below? Well, if we now move to the serrated area and do a similar dissolve between before and after, which we can do with two television cameras here, we will see, I hope, that the points at the bottom did a slight downward walk. And this serrated form and its motion is very typical of things which occur in laboratory experiments in blowing sand around. And we shortly are going to dirty up the Royal Institution in yet another way by blowing sand around. But before we do that, let's take a look at a laboratory experiment done under closer to Martian conditions than we will be able to, in which you see at upper left the wind blowing these little strings, and down here an originally regular pile of sand which has been made to take a serrated shape very much like that on Mars. Now here, and I have no idea how this experiment is going to turn out, we have a pile of sand on a dark surface, a wind machine, and we're going to turn it on and see what happens. So far, nothing is moving at all. Now we have streams of sand which are blowing down. We almost blew one of Mr. Coates's assistants away. We see long streamers which have come out. We have changed the initial configuration of the pile. Had we let this go for some longer period of time, we would have found that there were little outrider streaks like those that we see on Mars. We find, if we look elsewhere on Mars with the Mariner 9 mission, still further signs of wind-blown dust. Here, at left, we see a field of craters, and behind each crater is a bright streak, all pointing in parallel directions. And if we look at right, we see in quite a different place on Mars a field of craters, and behind each crater is a dark streak, all pointing in the same direction, although a slightly wider angle for the streaks that are dark than that are light. This looks very much like material at the bottom of a crater blown out by strong winds. All the craters had the dust blown out at the same time, and therefore all the streaks are parallel. Here is a lovely example of such a thing. This is a place called Mesogea, which means middle of the earth, but it's actually on Mars. Here is a crater. There's a long dark plume coming out of it. There's some source of dark material in the crater, but here is a place where the plume has not extended to. And we can see exactly why that has happened. The material blew out of the big crater and then was prevented by the walls or ramparts of this crater from falling behind it. What we see here, this bright feature, is a wind shadow. And such details confirm that we are seeing changes in the configuration of bright and dark features on Mars due to wind-blown dust. Now, almost certainly the changes that were seen by ground-based observers are due to weather and not to life. That does not exclude life on Mars. It just means that there was nothing that had been seen from the Earth on Mars that we now can say with any degree of reliability was produced by a Martian biology. Each time we look for something, we are a little disappointed, but each time we find something spectacularly interesting. In this case, here we have a map of the wind directions, which are deduced by these streaks and irregular features, and they give us a weather map of the directions the winds blew at the times of the highest speed winds on Mars. That is of great importance for the meteorologists, and in fact it turns out that the weather patterns on Mars are quite like the weather patterns on Earth. They are comparable planets and have comparable weather. The fact that Mars has the same period of rotation, 24 hours, as the Earth, makes that comparison even more striking and bears out again a most important point about planetary exploration. There are certain sciences which are restricted to the Earth, or at least were until recently. Studying the weather was one. Studying climates and climate change was another. Geology and geophysics is a third. And biology, the most important, is the fourth. Each of these sciences has been restricted to the Earth. The people studying these fields could not know to what extent their conclusions are generally true and to what extent they are anecdotal to the Earth. By extending our study to other planets, we are able to broaden the powers and generalities of these sciences and therefore to make them much more relevant back here on Earth. I believe that the entire effort at unmanned planetary exploration is more than justified in terms of cost on this basis alone. Now, I'd like to conclude by just showing you 3 more pictures found by Mariner 9, because there are many things found by this mission that we do not understand. Here is a photograph in Tharsis, the high plateau which contained the volcanoes, and there are many streaks which are behind craters, but there are some which are not connected with craters. In this region are a set of remarkably straight features, not connected with craters, and we can do a close-up of this region right here, and you can see how this streak, for example, does not begin in the crater. These little ones do not. And the manner of formation of these features is mysterious, but it may be due to what happens when very high-speed winds blow sand about, because the winds on Mars are much higher than the winds on Earth. Winds on Mars have been estimated at over 200 miles an hour, and in some cases up to 300 miles an hour. In fact, approaching the speed of sound on Mars, over 100 meters a second to convert the lower number. That is a wind speed range that we simply don't know about on Earth, and maybe there are strange patterns that occur in that case. Even more mysterious, and this is something I love to show, are these features found by Mariner 9. You can see here are 2 mountains of pyramidal shape. They are oriented in the same direction. They are each 3 kilometers across at the base, 1 kilometer high, lovely sculpted objects. What are they? That is also a rhetorical question because no one knows the answer. If we take the typical geological approach, which is if it looks like something I know about, then that's what it is, I guess we would have to conclude the existence of Martian pharaohs. That seems to me a little premature, risky, not the only possible conclusion, although it would certainly be terrifically interesting. Because there is something else which happens on Mars, and that is sand blasting. The sand, which is carried by these enormous winds, can erode and rub down and carve out mountains which are previously irregular. And therefore, over 10 or 100,000 years, the high-speed winds on Mars might have carved 2 or more quite irregular mountains into these lovely quasi-pyramidal shapes which we see in this particular region. Maybe that's not what's the cause. Maybe something far more exotic is. We are by no means sure. Mariner 9 has revealed mysteries. It has solved many old problems. It has raised many new problems. To really investigate these problems, we must go even closer to Mars and land on the planet, and that is the objective of Viking next lecture. Hello, very pleased to be here again. This is the 5th of these 6 Royal Institution Christmas lectures on the planets. And today we are concluding our discussion about Mars with a discussion of the Viking missions to Mars, which are the most definitive exploration of another planet that has been performed to date, and which involves not only the first close-up looks at the surface of Mars, but the first serious search for life on the surface of another planet. The Viking spacecraft is shown here. This is a model of it. It is a orbiter-lander combination. When it is launched into space, these great solar panels unfold to convert sunlight into electricity and power the spacecraft on its year-long journey to Mars. There are rockets attached to make mid-course corrections of the trajectory. The orbiter has attached to it a lander, which is wrapped up in this cocoon, and it emerges from the cocoon only when it enters the Martian atmosphere. Before it does that, it must check out landing sites on Mars. And so the entire orbiter-lander combination goes into orbit about Mars and might be there for weeks or months until a correct, proper, safe landing place is chosen. Then the lander descends to the Martian atmosphere, lands, we hope safely, on the surface, and the orbiter continues to do its work. Well, that happened. The spacecraft were launched, 2 of them, 2 orbiter-lander combinations in the summer of 1975 and arrived at Mars in the summer of 1976. We can see the launch of the spacecraft here, and it's taking off from Cape Canaveral in Florida, and the spacecraft itself is at the very tip of this very large Titan Centaur launch vehicle. We can see the kind of pictures that Viking obtained. This is a picture acquired before Viking 1 went into orbit around Mars. And among the many features of great interest seen is a great rift valley right here, which is 5,000 kilometers long, about 3,000 miles long, and is an enormous feature, very young by geological standards, and is a sign that Mars is geologically active today. We can also see big frost-filled craters, basins, and many other regions of interest. Another picture taken later in the mission, but of the same sort, is this lovely picture of a crescent Mars. And in the upper corner here is a picture of a great volcano with clouds trailing off the summit. And down at the bottom here is a patch of frost that's visible with a great impact crater in its center. Here is a close-up of a very small region, only about 50, 60 kilometers wide, of the Great Rift Valley, which is this feature right here. And you can see that there have been great avalanches which have collapsed from the walls and slumped down into the valley. This is a scene of enormous geological activity. Here is a close-up of a mosaic of 3 pictures, one at right, one at center, one at left, which are neatly pasted together. And you can see that the Great Rift Valley, which is here on Mars, has eaten away into this pre-existing impact crater here. And as the Rift Valley continues to have its walls slump, it will eat into the features at its edge. You can also see the marvelous cracks in the floor of the crater, which have been produced by this slumping. Here is a close-up of a different region in the floor of this enormous valley, and it is covered with sand dunes, and as the cameras do a nice close-up, we can see a very large number of sand dunes stretching for many tens of kilometers across the bottom of the floor of this great valley. Here is a picture taken obliquely, not looking straight down, but looking off towards the edge of the planet. And again, you can see it's a mosaic made of several independent pictures put together. And the first thing we see is a great basin. This one is called Argyre. And it is obscured because there is dust in its atmosphere and dust in its surface. And the detail, the geological detail that's there, is difficult to see as a result. Argyre and other great basins, the biggest one is called Hellas, which is Greek for Greece, are the sources of the dust for some of the great dust storms. You can see at the periphery of Argyre, the ground is very detailed and chopped up, not obscured at all, as in the interior. As we look towards the edge or limb of the planet, we can see the Martian horizon, and also we can see a detached cloud or limb haze. There are clouds of condensed carbon dioxide, of condensed water, like here, and there are also often dust clouds on Mars as well. Here is a close-up of a Martian crater of a sort that we never find on, say, the Moon or on Mercury. The crater itself looks ordinary enough, and it has a central mountain peak, as many lunar or Mercurian craters do. But on the periphery, there is what is called a lobate ejecta blanket. It's a big, long set of words. Lobate means it looks like it has lobes on it. Ejecta means it's been thrown out from the crater. and blanket means it's lying on the surface. Instead of having an irregular pattern, the material which was thrown out by the impact has this form of lobes, fingers. Now, what could that be due to? It is due, we think, to the fact that the Martian surface material is composed of permafrost, ground soil mixed with ice. As the impacting object comes in and makes the hole, it also melts some of the ice. The ice then provides a lubricant, a medium on which the sand and dust can spread outwards, and that continues to flow out in this form until the water freezes again, and then the lobate pattern stops. So this is indicative of the frozen water content of the Martian subsurface, which we know about on other grounds already. Now here is a picture which reminds us that Viking, as well as Mariner 9, has found sinuous valleys, the remains, we think, of ancient rivers, but this particular one is filled with fog. There is local weather on Mars, and a picture taken a little bit later showed no such fog. There's an early morning fog in a lowland valley on Mars. And here we see a remarkable set of features, generally boxed in valleys of very large proportions, many tens of kilometers long. And perhaps you can see a set of striations which run the length of the valleys. That's a very nice close-up, which follow the contours of the valleys. Now, on the Earth, there are some features like this which are produced by glaciers, but to the best of my knowledge, none on this scale. If this is produced by glaciers, it indicates a time when there were glaciers of very major proportions on Mars, and this reminds us of something we talked about in the last lecture, that there might be major climatic change on Mars. Here is a Viking 1 photograph of the polar caps. Here to top right is high ground. Here to bottom left is low ground. And here is the transition, a almost vertical cliff face, which is about 2 kilometers high. And there are these tongues of ice hanging down the sheer cliff face. And you can imagine that would be quite an interesting place to be in. And up here to the right might be a nice place to ski on. I don't think anyone will do that in the near future, however. Well, these are some of the pictures that we looked at before landing on Mars. And when I say we looked at it, many, many scientists involved. And here is a picture of a group of them looking in stunned amazement at some of the first pictures. And I show it to you to indicate this is not uniquely an American enterprise. This gentleman is C.B. Farmer, and this gentleman is Michael Carr. Both of them are British citizens. I picked it out just to show the British audience that it is possible to be British and to be in planetary astronomy at the same time, although there's not much evidence of that in the United Kingdom at the present moment. Now, the question of landing on Mars is a difficult one. We had never landed on Mars before. And there are things about Mars which we might consider dangerous. There were very peculiar radar reflection characteristics from Mars. A radar telescope on the Earth gave an indication of extremely soft ground on Mars. There are other places where we thought the ground was extremely rough, and the spacecraft coming down was very vulnerable to rough or soft ground or many other criteria. The spacecraft is a few meters wide and 1 or 2 meters high. A rock of a meter size could make the thing land at a peculiar angle, roll over, and die. If the ground was very soft, the spacecraft might sink into the ground, say up to its eyebrows, and be unable to see anything on Mars, and that would be unpleasant. So we had to choose safe places. But since no one had ever landed on Mars, that wasn't so easy. What is more, the orbital photography of the sort I've just showed you had a resolution, an ability to see fine detail, which was at best only about 100 meters. Anything smaller than 100 meters we couldn't see. But a rock a meter across could destroy us. So we had to somehow guess from what we see at 100-meter resolution to what might be on the ground at 1 meter resolution. And you can't do that unless you really understand the terrain. So the idea was to find places on Mars which were fabulously dull, in which there was nothing whatever of interest to be seen. That's the place to land. Now you can see that that lets out all of the exciting places we just looked at. You can't land in a river valley, you can't land on the slope of a volcano, you can't land in the polar ice. You can't land in any of those nice, interesting places. You have to land in the dullest, least interesting place you can find and hope that you could survive there. Now, an indication that we had to take this very seriously came from the fact that there had been at least 3 dramatic Soviet failures previously in trying to land on Mars. And one of those failures is indicated in this postage stamp, which shows the Mars 3 spacecraft entering through a kind of purple muck. You can see purple muck up here on the right. The artist who drew this postage stamp quite correctly was indicating that the Mars 3 spacecraft had entered in the midst of a great sandstorm. The Soviet spacecraft had been pre-programmed so that where and when they landed on Mars was determined at the time of launch. And the fact that there was a great dust storm on Mars came in too late to change the protocol. And what seems to have happened for Mars 3 is that it came into the Martian atmosphere, had a big billowing parachute which slowed it down nicely, and it touched down at the Martian surface with a speed in this direction which was very gentle. Unfortunately, the big parachute very likely picked up the enormous winds that were driving the dust storm going this way, and so the spacecraft landed gently, vertically in the horizontal direction. It was going extremely fast, and perhaps hit some obstacle, fell over, lost radio communication with the flyby spacecraft, which was its link to the Earth, and failed within 20 seconds of landing. The later Soviet spacecraft failed mysteriously within 1 second of landing. So as a result of all this, we wanted to be extremely cautious. Now, a picture of where we hoped to land is shown here. This is a region called Chryse, C-H-R-Y-S-E, which is Greek for the land of gold. And scientifically, it is a land of gold because you can see all the signs of past running water that are through this region, which is shown in this lovely mosaic. Now, we see an ellipse, which indicates how confident the navigation team was about where they could land. They said that there was a 99% chance that they could land within that outer ellipse. But when we looked closely at that terrain, it looked dangerous. At least it didn't look familiar. We weren't sure about it. And so we had to move. And here we have a picture of first where we originally started out, then where we hoped to get to next, and finally where we eventually settled on. And that took quite a while. And in that period of time, while we were trying to figure out a safe place to land, July 4th, 1976 came and went. That was the bicentenary of the United States. It would have been nice to have landed on that date, but we thought it better to miss that date than to crash on that date. That seemed to us not to be a marvelous birthday present for the United States. So we, in fact, did not land until July 20th, 1976. And we can take a look at a close-up of this fabulously dull region. You can see that it has nothing whatever of interest on it. It has a few impact craters. It has a kind of real soft, muted terrain of the sort we know from on the moon. Well, there is this cross. If the cross was on Mars, this would be a place of some interest, of course. But this was put on by the artist to indicate where we hoped to land. In fact, Viking 1 successfully landed within about 30 kilometers of the designated landing place after an interplanetary voyage of over 200 million kilometers, which lasted more than a year. Precision targeting. The landing sequence went something like this. Here is the orbiter which is separating from the lander, wrapped up in its aeroshell. The lander then slowly enters the Martian atmosphere, still in orbit, but spiraling in, slowed down by the Martian atmosphere. Then once in the Martian atmosphere, the lander, still in its aeroshell, is connected to the parachute, which is just unfurling or deploying. It opens up, very large, 55 feet in diameter. That slows it down still further. And then finally, the retro rockets fire, which you can see here, and the spacecraft gently, we hoped, settles down on the Martian surface. Now, before I discuss what we found, I want to do several things. One is I want to show you a little bit about the Viking lander, and then I want to describe how the Viking cameras work, because that's essential if we're to understand the pictures that we will see. So here is a model, thank you, Bill, of the Viking lander. And we can see a number of things. First of all, there are foot pads, 3 of them. It's a 3-legged beast, and it lands on those 3 foot pads. Unfortunately, it cannot move the feet, so we cannot take a walk, and that's a point I will come back to towards the end. It talks to the Earth 2 ways. With this large radio telescope, it talks directly to the Earth when the Earth is in the sky. That is not always the case. More often, it talks to the orbiter when the orbiter is overhead with this smaller radio telescope right here. It has a computer which gives it a great deal of information about what to do, and that computer can be instructed from the Earth so it can learn new things. As I mentioned before, it has retro rockets so that it can brake as it lands, but they're turned off before it's over the landing place so it doesn't fry the ground it's to investigate. It does not work by electricity generated from sunlight. Instead, it works by electricity generated by nuclear power. And there are 2 nuclear power plants here and here, which give energy even at night when the sun, of course, is out. There is a sample arm which can reach out about 3 meters long, acquire a sample of Martian surface material, withdraw it back into the spacecraft, and it then looks at that sample with 5 different experiments, 1 on inorganic chemistry, 1 on organic chemistry, and 3 on microbiology. And we'll talk about those experiments later. There is a meteorology boom which gives almost hourly weather reports about Mars. And finally, there are these 2 turrets which are cameras. And those cameras work in a way different from the ordinary sort of camera. And I'd like to say a little bit about how they do work. Essentially, there is a nodding mirror inside which bobs up and down and measures a single line of information in the scene. So if I were looking right here, I'd see, because this young man is wearing a dark suit, a dark jacket, dark sweater, I would see dark, 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 dark. Then I get to his face, which by accident happens to be lighter, and it would be lighter. Then the person behind him would be dark, light, dark, light, dark, light, dark, light, and so on. And I'd get, in this single line, fluctuating darkness and lightness. Then the turret would move a little bit, and I would do another line. And in this way, I would slowly build up, line by line, an impression of what the scene is. Now, over here, we have made a kind of duplication of the basic idea of the Viking camera. So here is a nodding mirror, and you can see it has an ability to nod up and down and build up some information on the scene. Now, the light comes in, is reflected off the mirror, goes through some optics, goes to a photocell, which converts that amount of light to electricity. Then the electricity is measured on a device here called an ammeter, which just measures the amount of current that flows through. Now what we're going to do is have a volunteer. I haven't said what you're volunteering for yet. How do you know you want to do it? Maybe it'll be terrible. Let me say what the volunteer is going to do, and then you can see if you really want to do it. Actually, it's very interesting to do. The volunteer is going to stand over here where he can't see what's happening over here. And we're going to pile up some blocks in a certain pattern of white, gray, and black. The volunteer is going to stand over here and look at this ammeter, and when there's a lot of current, meaning it's white, he'll put a white block there, and when there's only less, we'll put gray, and when there's even less, we'll put black. And we'll see the volunteer building the blocks up here. There'll be a pattern over here, and at the end we'll see if the same sequence of bright and dark is built up on both sides of this barrier. Now, who would like to do this? Okay, let's see. Can I have you, please? I'd like you to stand right here. Let's put these blocks down here. You'll use these. We're going to start with a white block just so we'll check out that everything is right. And what you have to do is look at this meter. And when it's all the way over here, it will signal white. When it's over there, it'll signal gray. When it signals over here, it's black. And I'll tell you when I'm going to each additional block, okay? Now, the one thing you have to promise not to do is look at the television cameras, which will tell you what's happening on the other side. Okay. Just step over there. Good. Can you see the ammeter still?
Yes.
Is that okay? Okay. So now I'm going to go over here and try not to be in the light. And I will change the mirror, or nod the mirror, by turning this screw. And now, just to check that we are on the white block, I'm going to put my hand over the block a little bit and notice that the needle does change. Okay, so now, are you ready? Okay, so I'm now going to turn the screw and I'll tell you when I've gotten to the next block. I have now gotten to the next block. Put some appropriate colored block on. Have you done that? Okay. Now, next block is now. Would you put that block on, please? Have you done that? Okay. Now, the next block is here. Have you done that? Whoa. Have you done it? Good. And now the next block is here. Have you done that? Okay, so we have 5 blocks here, 5 blocks on the other side. Let me pull this partition away and let's see if we have the same sequence of 5 blocks. White, black, white, gray, white. White. Thank you very much. That was really very good. Well, now, you see you could build up the image of anything. You could build up not just the images of blocks, but of elephants or armadillos or whatever happened to be around. So now I'm going to show you a sequence in which Viking lands not on Mars, but in a different kind of Mars. This videotape shows a Viking lander as if it were to land on an exotic other world called Earth in a place called Mars, Pennsylvania. In the United States, we can see here the Mars drugstore, and there is the Viking lander sitting on the main street of Mars, Pennsylvania. And now, if only there was some sign of life, there's the Viking camera, and now if only there was some sign of life to detect, who knows, maybe the Viking cameras might be able to detect the life in Mars, Pennsylvania. My goodness, what's this? There's Viking taking it all in. Now, here is a picture below taken by an ordinary camera, and above we will see line by line the Viking image build up. And the interesting thing is, while the background it sees fine, anything that moves it can't see so well, and so it's going to miss a lot of the moving objects, whatever they are. Now, that's the situation on Mars, Pennsylvania, and the question is whether the situation on Mars is different. Here is, in fact, the complete build-up of the picture on Mars, Pennsylvania, by the Viking lander seen above. And you can see all of the invisible dominant organisms marching by, but which Viking could not see because of its nodding camera mode. Now, with this introduction, let us see what is on Mars. If there is life on Mars, the one thing we can be sure about is that it will not look like the life in Mars, Pennsylvania. Whatever else might be there, we have no way to know. Viking was the first attempt to look close up at the Martian surface, and let us now spend a little time examining what Viking found. Here is a portion of the first photograph ever returned from Mars. A portion of the Viking footpad can be seen to the right here. You can see it sitting high above the Martian surface. It did not sink in. And here, adjacent to it, is the first look at Mars we ever saw. And you can see it has flat rocks and clods of dirt and looks like your grandmother's garden. If we look at another footpad, here's the footpad. Here is the support of the footpad. The footpad itself is buried in Martian soil. So Viking 1 landed in a place which was hard on one side, soft, so soft on the other that it slipped into the ground. And if we were to look out towards the horizon, we would see why this is the case. This beautiful picture is bisected by the meteorology boom, which you see here. And there's some other Viking spacecraft parts in the foreground. And behind it is Mars. And you can see a large boulder, you can see other rocks, and you can see lovely sand dunes behind. It looks like many places on the Earth. The governor of Nevada once told me that he knew a place in Nevada that looked exactly like this. And you can almost imagine a sort of grizzled prospector pulling his mule along, coming out from behind one of those sand dunes. But no grizzled prospector was found. Here is a close-up of these sand dunes, and it's quite amazing how similar they are to the sand dunes on the Earth, say in the Sahara or the Mojave deserts, despite the fact that the particle sizes, the wind velocity, the atmospheric pressure are all extremely different on Mars. It's a great deal to learn about deserts from studying Mars. And now here is another color photograph, again bisected by the meteorology boom. You can see now color photographs of the sand dunes towards the horizon. And now here is quite a pretty picture showing in a different direction, away from the sand dunes, the field of rocks and boulders. Notice how the boulders in middle distance are dark colored, quite different from the boulders in foreground. If we look now at the next photograph of Mars, we see a close-up of a rock to the right, which we originally called Big Bertha, but there was a complaint from a women's liberation group, quite properly we thought, and so it is now called Big Joe, and no one has complained. Big Joe is so large that had we landed on it, we would have been destroyed. Viking 1 would have been destroyed. And is an indication that it is not terribly easy to land on Mars. Now here is a field of strewn rocks lying before the spacecraft. You can see it's very hard, rocky ground. But if we take a close-up look in this scene, we see that behind many of these rocks are tails of sand, raised elongated streaks of sand, all pointing in the same direction. And this is very similar to the situation we talked about in the last lecture, in which there were such streaks behind craters. And the situation is just the same. In fact, we found that the direction that all of these streaks point is the same as the direction that big streaks point in this same region. These are wind markers from the last great dust storm in this region. And they point in the direction that the wind blew. Now, things do change on Mars. Here is a photograph of Big Joe. And here's Big Joe. And here is a small rock. And you can see that between this small rock and Big Joe, there is no rock. But now, if we dissolve to a picture taken just a little bit later, we see that suddenly there has appeared another rock in an intermediate position. And that rock, here we are going back to the original. And now we dissolve to what it looked like later. Now, that is a change which has occurred in a small scale in a short period of time on Mars. Either the wind has uncovered that rock, or the sand has slid off the rock because of a small Mars quake or something of that sort. There are Mars quakes. One was detected by the seismometer on Viking 2. Now, we put on top of the Viking lander a kind of grid, which you can see here, a kind of checkerboard, to show the positions of things we dumped there. And then we had the sample arm reach out, acquire some Martian surface material, and like an elephant washing itself with sand, dump the sand on its back. And here is what that looked like. Here you can see the same grid now all discolored with the sand. And we watched this, and as time went on, the sand moved, gradually blowing in this direction and in this direction, gradually accumulating against this device. Now, this is the first close-up investigation of the motion of fine particles on another world, and we have found that not only does this occur, but we have found what wind velocities are necessary when it does occur, and very high winds are required, as we had suspected long before. Now, all of this discussion so far has been about the Viking 1 lander, and I'd like to talk just a little bit about Viking 2. Here again, we wanted to land in a safe place, and we were running out of time, because in November of 1976, Mars was passing from the Earth's vantage point behind the Sun. And we were not sure that we would be able to reacquire the Viking landers after that solar occultation event. So we wanted to put Viking 2 down on Mars and get some preliminary information before November. On the other hand, once we had Viking 2 in orbit about Mars and looked at the region we were in, we found some extremely strange terrain which we did not understand, and again we were worried that we would crash the spacecraft as we landed. So, for example, one strange place that we saw was this region, which you can see here in the lower left seems to be covered with giant fingerprints. You see all these ridges that are in parallel and curved. The ridges are about 1 kilometer across, so it's an extremely large fingerprint. And since there are craters on top of the fingerprints, this one, for example, these are extremely old fingerprints. They are, of course, not fingerprints, but what they are, we don't know. And if we don't know, we must not land there. So we moved on to a different longitude in the same latitude, and we came upon ground like this, in which there are roughly polygonal patterns covering the landscape for tens and hundreds of kilometers. Such things are known in the small, in the Arctic regions of the Earth, but never at this scale. Again, we had to be extremely cautious and not land here. Eventually, we found a place which looked sort of all right. There wasn't anything too bad, or at least too puzzling near it. We sat down and landed successfully, but we were lucky. Here is the first photograph from the Viking 2 site. The Viking 2 landing place was called by the old astronomers Utopia. So in case you've wondered what Utopia looks like, This is it. Here is the lander footpad, and you can see it's covered with Martian surface material, which was obviously thrown up in a great cloud as we landed. Here is a rock which we think we turned over in the process of landing. We did land on a rock, and in fact we were tilted 7 degrees for the rest of the mission. And here is a rock which is vesicular. It's full of holes. And whether that's because of sand blown by wind eating out the surface material, or whether this is a kind of rock produced by volcanic events, we don't know. But it is a kind of rock we never saw in Viking 1. Now, when we step back and look towards the horizon, again, that's the meteorology boom you've seen before off to the left. There are, you may think, strong similarities between this scene and the Viking 1 scene. That's certainly right in that there are rocks extending out to the horizon. There are also a number of differences. One of those differences is the existence of this trench or furrow, which you can see runs straight across the picture. And in fact, when we map all of those furrows in all directions around us, they seem to also make a kind of polygonal pattern. We seem to be on patterned ground, and perhaps that is due to permafrost, as in the terrestrial Arctic, but perhaps not. There are also no sand dunes in this region. That's another difference. If we take a close-up look at the trench, here it is up here, we can see in it a pyramidal-shaped rock, and whoops, there it is, pyramidal-shaped rock, and also a sheer face of a rock that seems to have recently been cut by what, we are not sure. Well, this is an extremely quick look at the Viking 2 landing place. In fact, both Viking landers are still all right, and both Viking orbiters are sending information back. We have acquired an enormous amount of information about Mars, and I've touched only on a tiny amount of it. But the question which everyone likes to ask, and which Viking was in fact intended in part to try to answer, is the question of life on Mars. Did we find any life on Mars? Now, there were many speculations which we've talked about. For example, Percival Lowell's idea of great canals. Notice we did not see anything like a canal in any of these pictures. Then there are views of other people. For example, this artist's conception of what we might find. Certainly be extremely interesting if we found exotic life forms such as this animal in left foreground and strange cabbage-shaped Martian plants in background. We saw not a hint of anything like that. Here is another possibility that someone proposed. A creature not just large enough to see, but interested in us in the Viking lander, and in this particular case looking straight at the cameras, we certainly would have gotten a lovely close-up of its eyeballs if there had been such a creature, but we saw nothing like it. Nor did we see any artifact, any sign of manufacture of intelligent Martians. Here is, in fact, an artifact right here in the center foreground, but it is not an artifact from Mars. It is a product manufactured on the planet Earth. It is, in fact, the glove that covered the sample arm before the sample arm was deployed or used. And nothing of Martian manufacture was found, not even a wrapper to a stick of chewing gum or anything like that. No hint of anything large enough to see that was alive. Now, what's the significance of that? Does it mean that life does not exist on Mars? It's certainly relevant to the question of life on Mars. Well, we landed only at 2 places on Mars chosen for their dullness. We cannot tell whether this is a typical place on Mars as far as biology, or whether it would be like landing in the midst of the Gobi Desert or the Antarctic ice cap, looking around, seeing no life, and saying, aha, the planet is uninhabited. For safety reasons, we had to go where it was dull. But if this is typical, if there are no large organisms on Mars, it hardly excludes the presence of small organisms, because the Earth, for example, had organisms big enough to see only for the last 500 or so million years. And yet there's been life on Earth for about 4,000 million years. For that period of time, the Earth was covered with microbes, but had no macrobes, no organisms big enough to see. So the negative results, which are very interesting and important, no organisms big enough to see on Mars, does not say anything about little microscopic organisms. Fortunately, Viking was designed to look for them also. The experiments are in some sense limited. They can only answer some questions, but they are a first attempt to approach this question. Now, the way these experiments work is that the sample arm goes into the Martian surface under guidance from the Earth and examined by the television cameras. Here is a sample arm. I'm holding it, but in the real case, it's the Viking lander which holds it, positions it, and then gives the go-ahead, and we dig up some Martian soil, and it is withdrawn back into the spacecraft, and they're sent through a variety of hoppers and sent to the 5 experiments, 3 microbiology and 2 chemistry, and leaving behind a kind of small trench or furrow in the Martian surface. Such trenches or furrows can be seen. If we look at the next picture, we can see here to the right a picture of the furrow, and off to the left we can see the Viking sample arm that has dug the hole. We are playing in the sand of another world. And here is a sequence at left where we see the sample arm touching the Martian surface, moving a rock away because we were interested in looking underneath rocks, places which were not exposed to the ultraviolet sunlight on Mars. And then off to the right, we see the moved rock and the furrow adjacent to it, which was made when we grabbed the sample and withdrew it back into the spacecraft. Now, over here, I am going to try to describe 2 of the experiments designed to look for Martian microbes, little organisms, if they exist on Mars. We don't know if they could exist. You remember we talked about some experiments with Mars jars showing that terrestrial little bugs might be able to survive and grow on Mars. We talked about experiments on the origin of life, in which the most common conditions early in the history of a planet seem to point towards the origin of life. Well, did that happen on Mars? Did life once originate on Mars? Did it evolve? Has it survived the changing climate of Mars? Could those microbes be in existence today? Well, I want to describe here, this is symbolic experiments. These are not the real experiments on Mars. We didn't have little eyedroppers and somebody to squeeze the eyedropper. But this indicates the basic point of these experiments. One experiment looked for the breathing, the respiration of Martian organisms. The idea was we brought to Mars food which we hoped the little Martians would love to eat, if there were any little Martians. Here, beneath this eyedropper, in this pipette, is some of that food. Below it is, imagine, Martian surface material which has been put there by the Viking sample arm. The food is radioactive. The Martian atmosphere is not radioactive. We drop the food onto the Martian surface. Now, if there are Martian microbes that love this food, they might oxidize it, as we do when we eat food, and give off carbon dioxide. That carbon dioxide would be radioactive. So if we found an increasing amount of radioactive carbon dioxide in the Martian atmosphere after giving food to the soil, we might deduce that there are microbes there. And so, in this experiment, we will want to put the active end of a Geiger counter into the atmosphere in here, and the increase in the rate of counting radioactivity indicates that there is radioactive carbon dioxide, only a little bit, but more than before, and therefore that some interesting chemistry, like respiration, has happened inside the chamber. There are always a few clicks, even when it's not close to radioactivity, because of cosmic rays coming in and striking the detector. Now, that's the story of this experiment. Here's, in a way, the opposite experiment. Here, the plants, I'll talk about in a second. We didn't have plants on Mars. They're just to help us understand. Here, we introduce radioactive carbon dioxide, C14 labeled carbon dioxide it's called, and see whether the Martian soil is able to capture, acquire, grab that carbon dioxide and convert it into organic matter. So here I am symbolically making carbon dioxide. Well, actually, I am making carbon dioxide by dropping sulfuric acid on some carbonate, and the frothing and bubbling that's going on there is the generation of carbon dioxide. Imagine now the radioactive carbon dioxide spreading out in the interior of this chamber, and the Martian soil acquiring that radioactive carbon dioxide, converting it to organic matter. That organic matter will be labeled with radioactivity. And so, if I can ask you to hold this without burning yourself with sulfuric acid, and take the Geiger counter. In this case, I'm going to put it on the leaf. And we see, sure enough, radioactivity has gotten into the leaf. That would prove, if this were on Mars, that the leaf was alive. Well, we know leaves are alive anyway. But if I put it down here on the soil, and imagine no plant there, then that would indicate that the radioactive carbon dioxide had been fixed, reduced, converted to organic carbon in the sample chamber. Now, the results of these two experiments are as I just described. Thank you, Bill. These two experiments gave, by criteria established before launch, positive results. If these two experiments had been landed in Piccadilly Circus and gave these results, you would deduce that there was a low form of life in Piccadilly Circus. Higher forms of life would be an open question, but low forms would be very, very likely. Now, that being the case, why don't we hear about lots of life on Mars? There are two reasons. One is that scientists are naturally cautious and think that it's better to make the mistake of saying that they didn't find life, even though later it turns out there's life there, than make the mistake of announcing there's life on Mars and later on find out it's a mistake. It'd be very embarrassing. The other reason is that Mars is not like the Earth, and there's a different kind of inorganic chemistry that can happen on Mars and not on the Earth. For example, ultraviolet light from the sun strikes the surface of Mars. That doesn't happen on the Earth because we have ozone here that absorbs the UV. Does not happen on Mars. So the UV, or ultraviolet light, strikes the Martian surface and changes its chemistry. It breaks down water, which is part of the molecular structure of the Martian soil, and oxidizes the environment, makes very oxidizing molecules like peroxides and superoxides. Well, if the Martian soil is filled with those guys, those kind of molecules, then it might very well break up radioactive food sent from Earth, release carbon dioxide, which is also radioactive, and fool us into thinking that there's life on Mars that's breathing and eating instead of just the chemistry of the soil. So that's a reason why it's most important to be cautious. But the actual situation is that nobody has gone into the laboratory and duplicated these experimental results from Mars. Nobody has, with inorganic chemistry, without life, been able to reproduce, simulate, duplicate these experiments. And until they have, the possibility is very real, in my opinion, that they are due to microbial life on Mars. The alternative explanation is that there's a funny chemistry on Mars which likes to do a chemistry which looks like respiration and looks like photosynthesis. If that's the case, that same funny chemistry probably existed in the early history of the Earth, because before plants, there was no oxygen, there was no ozone, ultraviolet light struck the surface of our planet. If that's the case, then we can understand much better how the early steps in the chemical history of life, the origin of photosynthesis, the origin of respiration, came about. Either way, I believe, these important Viking results have a profound implication for the question of the origin of life and its distribution through the solar system. The trouble is, we don't yet know which of these two different explanations is the right answer. And that is another reason to go back to Mars to look more closely. Now, to say just a few last words about the Viking mission, I'd like to show this rather recent picture. It's just a couple of months old, in which we can see all sorts of the parts of the Viking spacecraft in foreground. And in background, we can see a number of rocks. But notice that before many of the rocks, there is a kind of white patch. And that white patch is snow. It has been snowing. There has been frost on Mars. It's the winter season, and the frost comes in the nighttime, dissipates in the morning, and we are seeing signs of the weather on Mars. A second point which I'd like to point out to you is this object right here, which looks a little bit like a 35 millimeter slide or a some kind of square thing. It is not a 35 millimeter photograph slide. It is a microdot. On that little thing is written extremely small the signatures of 10,000 human beings who worked on the design, fabrication, testing, launch, mission operations, and scientific analysis for the Viking mission. There are two places on Mars, some thousands of kilometers apart, in which 10,000 people have their signatures. And that is, at least in a symbolic sense, an indication that we are becoming a two-planet species. And the last picture I wish to show, it's common to end travelogues with pictures of sunsets. And here is a lovely sunset on Mars taken by the Viking 1 camera. But it is a sunset in a place chosen for its dullness. In fact, we know that it is about the least interesting place on the planet that we can find. We would like to go back to Mars and go to more interesting places. I myself would love to go to Mars. And I would love to take some people with me. I would like to take 2 people with me. Who would like to come to Mars? I am delighted that so many people wish to come to Mars. It's very good to come to Mars. Could I ask you to be very careful coming up? And could I ask you, please be careful coming up. And now I'd like you to sit on a Martian rock, if you wouldn't mind. Could you sit on that rock? Good. And could you sit on this rock? Thank you. Whoops, careful. Lightweight Martian rock. And I will sit here. And notice how noisy it is on Mars. We've never sent a microphone to Mars to hear what it's like there. For all we know, it's fabulously interesting. The wind is blowing and all of that. And maybe the rocks are creaky, like this. Maybe you noticed in some of the pictures that the sky was not blue on Mars, but pink. It's true, Mars has a pink sky. And the reason the sky is pink on Mars is because there is always fine reddish dust in the atmosphere. And the reason that the surface material on Mars is red, that the dust in the atmosphere is red, is because Mars is rusty. Now, while we're here on Mars, I think it's important to do a British custom. It's a program might not be shown at this time, but this time is certainly tea time. And I wonder if we could have some tea on Mars. Thank you very much. So I will pour tea, and as I do, I'd like to talk a little bit about what's the next thing to do to study Mars. Because, you see, here we are stuck in one particular place on Mars, and it would be nice to go to other places. To do that, we would have to have a spacecraft which could move about on Mars, which could rove. Would you like some milk in there, or would you have to take a blood? Some milk, yes. And so we have to have a spacecraft with wheels, with tractor treads, which could land in the safe and dull places, like here. It's not so dull because, after all, we're having tea, but it is dull compared to almost everywhere else on Mars. Would you like some more? Let's see. And so that is a technology that we have. We could land space vehicles that look something like this, but have wheels on them, and go off to the exciting, terribly nice places, the enormous volcanoes, the river valleys, the places which are different from the Earth, which are exciting. We can try to look for life in the places which are different from Chryse and Utopia. We have not yet done that. We may be able to do that soon. Our technology is capable of it, and who knows what further mysteries are to be found on Mars.
Okay, so pardon the absolutely horrible mic. I am running into USB device overflow. The camera's dropping frames, the mount's not responding, and yeah. So basically, I've run this machine through the ringer. So I think I am gonna call it a night. So far, I have, hold on, let's see. So far, I've collected over 675 gigabytes of 5-minute raw videos that I'm gonna have to go through. Oh, man. Let's see, how many years are there in here? Wow. Yeah, so that's a ton of data to go through. Anyway, yeah, so I think I'm going to wrap it up, especially given the camera's dropping frames, devices aren't responding correctly, things like that, so. But it's been fun. It's been fun. It was a real shame that as far as the forecast is concerned, this was the only night that I could do this. Hopefully, I'll be able to do some other events, kind of like this, and I'll include like lectures and things like that, because I think the lectures are actually kind of make it a bit more interesting. So I really appreciate all you watching and hanging out with me and staring at the red planet. Sorry for starting late with the various tech issues and camera failure. Hopefully I have better luck next time, and hopefully they'll get my damn internet working right. Anyway, thanks all folks. Love you guys, and see you next time.